this computer. All right, it is recording. So again, welcome everybody. Thank you. I am gonna make sure that everybody's muted as we go here. If you need something, like I said, just holler in chat. We will get to it. If we need more explanation, we'll go ahead and ask you to unmute just so we can talk direct with you. But I think for the most part, usually when we hit the breaks, we're in a pretty good spot. So Pete, I'll leave the back end con to you, buddy, and we'll get going.
Sounds good.
So,
we got it.
Sweet. So I'm Justin. I am the team lead, and I've got Pete here with me. We'll do formal introductions in a second, but we are Twisted Skies, and we have a big love for weather, and we really like to do this class to try to just get people up to speed on weather awareness. And if you've ever wanted to be a spotter, I feel like the information contained herein is a really good way to get some spotter training if you can't make the National Weather Service ones. But our main objectives for this presentation is to make you more situationally aware of your surroundings, so that the more you know about weather, the better prepared you'll be. Seems pretty straightforward, but there's a lot of nitty-gritty with all of that, and we'll cover as much as we can. And when you're better prepared, you will have more time to take appropriate safety actions while reporting weather conditions. And again, you don't have to go out and be a spotter after this class, but at least you'll have the information at hand, at least for your own situational awareness. All right. So again, we're Twisted Skies. I'm Justin. I founded the team about 6 or 7 years ago. I'm also a volunteer at the Independence, Missouri Emergency Preparedness Department. I'm on the duty staff there. I'm Storm Spotter team lead, part of the Situation Unit, member task force. I'm also Skywarn and CERT trained. Tony, my wife, she helps take care of things on the back end with our social media. So you'll probably really never hear from her. She tries to keep her face off of things as much as possible. But she really helps us just kind of stay on the rails as far as our socials go. Pete, who is here with us, he is a volunteer with the Oak Grove Emergency Management folks as a volunteer and coordinator, member of Jackson County Aries Skywarn, and is CERT trained with 30 years of weather experience. Then we've also got folks like you, friends of the team. We're fortunate enough to have some great fans and friends that send us really great weather updates and pictures from their locations, which is a big help. We use that information to distribute to like National Weather Service and local emergency management when it's appropriate. Just to be other eyes and ears from out in the field so they get an idea of what's going on where. If you want, we've also got a Discord, which is pretty new. It's kind of a glorified chat room for the most part. Pete will put the link in there, already did. But yeah, if you're interested in that, being a part of the conversation, we will have days where like Pete and I are in there. We're happy to take questions, let you know what we're thinking as far as weather goes. It's just a nice way for us to be able to interact more directly with people instead of just through Facebook posts. And then I do want to give an acknowledgement to the Independence, Missouri Emergency Preparedness. That is through the city of Independence, like I said, and is under the umbrella of the Independence Fire Department. The EP division is comprised of primarily 2 paid staff and many, many, many volunteers. We are now up to, I think, well over 1,000 volunteers across our different units and things like that. So with COVID continuing to be ongoing and Medical Reserve Corps now a part of us, it's something to behold, I have to say. But volunteers comprise a variety of our sections and units. For teams, there's Fire Explorers, and I think we still got an EP Explorers post. Those groups, all of these different groups span multiple functional units that really focus on our volunteers' skill sets for real world activations, better aligning our EOC with like FEMA's incident command structure by skill typing and levels. So if you've ever been interested in maybe doing emergency management or getting involved with your community, feel free to reach out. We are always looking for volunteers. Some stuff we are going to cover. Let's see, we've got our, weather is dynamic. We're going to go through quite a lot of that. Basically, what is a thunderstorm? I know it sounds really basic, but we're going to get into, why it's important to kind of differentiate between those things. We're going to talk kind of like the buildup of a storm, like the things leading up to a storm and like what you need to pay attention to and safety actions you can take for that. And then we'll really dive into the breaking point into severe or classifying severe weather and being aware of it. We'll talk about severe storm mechanics, storm composition and features, and then also burst events versus tornadoes. I know burst events are kind of a weird etheric thing that some people aren't really aware of. So I just want to make sure we talk about those so you know the difference between that and like a tornadic event. So with that, we'll have a better understanding of tornadoes. We will go through a bit of a radar crash course. Some of you may be very well versed in radar. Some of you might avoid radar. So I hope that by the time we get done with that section, you will feel like you have a better understanding at least. We'll also talk about winter weather, which I know we're on the tail end. Thank goodness. Very tired of winter at this point, but we will still go over some winter weather. And then we'll get into kind of the tail end of the finer details of weather information, like statistics. What are the differences between certain terminologies, why those things matter, and then being informed, like how to get your information, like who you should be able to trust for information, and staying situationally aware. And then we'll wrap up. We'll take questions, maybe that we didn't get to or things that we missed. But again, everybody, we are recording this episode so we can put it up for everybody in case you can't make it for this whole thing. I know we've had a lot of requests already today. So I appreciate you guys being here. The more questions, the better. Yeah, just holler at us in chat and we'll try to keep everybody muted just so we don't get like weird reverb and things like that. And then we'll have sections as we go where we'll actually stop to take questions at that point. But let us get rolling here. So brace yourselves. We got 3 hours of knowledge coming your way. We're going to start with a little bit of local historic weather. Some things maybe, I'm not as old as some of these events, but they're still really interesting to take a look into for our area. There was the Ruskin Heights tornado, which was a big event in 1957. The Kansas City derecho event in 1982. The Great Floods of 93, which is honestly probably one of the first things I really remember as a 7-year-old. I was like, man, like that seems pretty crazy. Like there can be that much water in any one place, There was the North Casey early May tornado outbreak in 2003. Joplin's catastrophic Ef5. I know it's a little less local, but for the state, that was a huge event. The Oak Grove tornado, which was pretty recent, back in 2017. And then the Linwood Major Tornado Complex back in 2019 with that huge tornado that ended up finally lifting up about by the racetracks. So just some things to think about. Before we really get dived into everything, if you need to know the information for contacting the National Weather Service, this is their info. Our local office is NWSKC or National Weather Service Kansas City, based out of Pleasant Hill. You can find them on socials at NWS Kansas City, so Twitter or Facebook. There's also the spotter line there. Thank you for putting that in chat. So if you are planning on being a spotter, even if maybe like the EOC is not active, or if you're out on your own or you're not a part of like an official group, if you've got something and you think it's important, like based on what we talk about today, feel free to give NWSKC a call. They love to be able to take live reports from people in the field. So the literal high level view here of the atmosphere under pressure, we've got high pressure, we've got low pressure. Probably something you see quite a bit on news stations on TV, but at the end of the day, low pressure is just the unsettled weather with like rain and snow. As you can see, there's all these little storm bits around the low, versus the high, which is the quiet weather, sunshine and dry. And that's, I mean, you can see there's hardly anything around the high pressure system there. Then I'm not going to read through all this, but I feel like it's a pretty good example of how dynamic weather is locally in the Midwest. So, you know, Mother Nature says you can't have negative 46-degree wind chills on Wednesday and then 52 degrees on Monday. That's a 96-degree switch. Yeah, I mean, we just experienced negative 30-degree wind chills not that long ago, and here in a couple more days, we're probably going to be reaching up into the 50s. So this exact scenario is basically playing out in the span of about a week and a half. So things can get pretty crazy here in the Midwest, which is why we say weather is very dynamic. Less so in other places, but here in the Midwest, we're really kind of in an intersection of a lot of different things at play. This screen capture here is from my birthday a couple of years ago, overnight between the 6th and the 7th of February. So while you can see up here in Kansas City, that northwest sector, the storm complex was experiencing thunder sleet and an ice storm warning. While down here in Springfield, they had tornadoes on the ground. So, I mean, you're only talking, you know, what, a couple hundred miles or something here? And you've got everything from tornadoes to thunder sleet and ice storms all in one. It's all one storm system, which is crazy. There was just enough of a temperature gradient between the two to support all of this weather. And I think that's pretty neat. You know, weather extremes like this can really only be present with those extreme temperature gradients and all the right ingredients, which obviously you can see is possible. So now, were this to have taken place in spring or summer, a setup like this would probably mean widespread severe thunderstorms. But this was in the dead of winter, so you know, this is the setup we got. So a quick example of a dynamic weather day. This is not an exact, but this is just kind of a general synopsis that I put together to show, you know, in the morning in WS Kansas City, they'll put out their information. Then we've got sunrise, you know, conditions are nice and calm. They're just, you know, a little warm, a little fog. And then by 9 o'clock, you know, it's starting to warm up a little bit. There's a little bit of a breeze. By noon, it's heating up pretty good. It's getting humid out. The winds are picking up a bit. In the afternoon, you know, it's even more humid. It's borderline approaching oppressive at this point. You're starting to see clouds kicking off. You know, the winds are getting pretty consistent. And now we've got a severe thunderstorm watch until 10 p.m. Then an hour later, you know, skies are looking really dark. Now we're starting to see severe thunderstorm warnings getting issued. Just a little bit later than that, it's really overcast. It's still very warm. A large storm complex is moving in. You know, we've got thunderstorm warnings, and then the thunderstorms begin to form a line. This is very typical weather for what we see in the spring and summer for us. And just a little bit later, then you've got tornado warnings. So in the span of, you know, less than 2 hours or so, we went from basically clear skies to now we've got tornado warnings. So this is why it's really important. And we're going to keep beating this over your heads as we go. Being situationally aware is not just a read it once in the morning and then forget about it, but making sure that on days when you know stuff's possible, you're keeping yourself up to date. So a little bit of statistics on understanding thunderstorms. About 1,800 thunderstorms are happening at any given moment on Earth, which is an average of 16 million thunderstorms per year. You can estimate how many miles away a storm is by counting the number of seconds between the flash of lightning and the clap of thunder, but it is not a 1-to-1 ratio, as a lot of people have said. You actually divide the number of seconds by 5 to get the distance in miles. So if there's 10 seconds between the flash and then the boom, you divide that by 5. So 10 divided by 5 is 2 miles. So really helpful to know if you're out and about. Maybe you're on an operation. Maybe you're just enjoying the square. You're going for a walk. It's good to know how close that lightning is. Thunderstorms are typically formed in the spring and summer months during the afternoon and evening hours, but they can absolutely and do occur year-round and day or night. Thunder and lightning can even be observed with a snowstorm, also known as thunder snow, and the typical thunderstorm cell averages about 15 miles across and lasts 30 minutes. That's just like a single cell. But what we get a lot of times in our area is more like multicellular or line of storms. Another thing to kind of knock off our checklist here is understanding what CAP is. I know it's probably something that you hear a lot with like the TV meteorologists on the cap. That's why we're not seeing the storms. Like we expected it to get going by 3, but now it's 5 o'clock. This is what they mean. Basically, there's a layer of air aloft that's just warmer than the air under it, which keeps clouds from forming. So it's like a cap on the cloud being able to raise up. That's about as simple as you can distill it down. There's some science behind it where the sun reflects off the mountains. It kind of creates this layer of heat that radiates outwards across the plains. And then over time and over distance, it eventually weakens, and then those clouds can get going. But if you hear somebody talking about a cap in place, they might also call it a temperature inversion. It just means that clouds are having a hard time getting high enough up in the atmosphere to do anything. So as a spotter or being situationally aware, one of the best ways to keep yourself weather aware for thunderstorms is to know what you're looking at when you're out in the field. You're not always going to have your phone or the internet, TV, or a radio. So, what do you do if you're driving around and you start seeing these like ominous looking clouds? Do you know the warning signs that nature provides us with those cloud formations? What are you going to do when you encounter these warning signs? And so in this section, that's what we're going to cover. Basically, the common weather associated with thunderstorms and what that looks like. So here's just a nice graphic from the UK Met Office, just showing the kind of layers of the atmosphere and those different cloud types within. But we're going to be focusing a bit more on the cumulus and the cumulonimbus out of all of these listed here. So you go from these nice little puffy guys to on dynamic days where they start growing in size outwardly, but then they also start towering upwards, reaching through all the way into these high levels of the atmosphere, eventually fanning out and making that anvil shape at the top. So if you're an avid enthusiast of like airplanes and things like that, this would be something that even as a cruising jetliner would have to circumvent or circumnavigate around, because these storms get so tall. So here we go. This is a cumulus cloud, just a nice little puffy guy, maybe, possibly an early sign of maybe something starting to develop. Not really towering yet, but if you look here, you can kind of see a little bit of a tower maybe getting going here. But this might also be where if it gets to a certain point, it doesn't continue growing. There might be that temperature cap, that hot air aloft that's keeping this thing from going anywhere. So again, cumulus, that's the short guys. It looks like cauliflower popcorn. Could be, in developing thunderstorms, they're really common clouds, versus, the cumulonimbus, which is our towering guys. And that's where you get that rapid growth in these clouds, indicating a maturing thunderstorm. So as a spotter, that's the type of thing. If you start seeing those clouds really building upwards, that's like kind of your first early warning sign to start paying attention to things, maybe get a weather update. So out of that, you could expect, some rain, some lightning, maybe a little bit more wind, maybe, start seeing a bit larger hail as these clouds go, and then mature into cumulonimbus clouds. Then we've got lightning. Yes, there is a proper way to spell it. There's some myths around lightning. So fiction would be lightning never strikes the same place twice, which is false. Lightning actually has favorite sites that it likes to hit, maybe even multiple times during the same storm. Fiction, if it's not raining, there's no danger from lightning, which is false. Lightning often strikes outside of heavy rain and may occur as far away as 10 miles away from any rainfall, or even further in some cases. Fiction, the rubber soles of shoes or rubber tires on a car will protect you from being struck, when in reality, the rubber-soled shoes and rubber tires really don't provide protection, but the steel frame of a hardtop vehicle does provide some level of protection. Granted, you're not touching the metal or something electronic in your car at the time. So, you might still be injured, if a lightning strikes your car, but you're still much safer being inside a car than being out in the open. Fiction, people struck by lightning carry an electrical charge and should not be touched. I would think that in current days, people would know that's not the case, but if you don't, please know that lightning strike victims carry no electrical charge and they absolutely need to be attended to immediately. If you're not qualified, call 911. Those folks need to get addressed immediately. Fiction on something called heat lightning occurs after very hot summer days and pose no threat. There's no such thing as that. But what it is lightning from a thunderstorm that's so far away you just don't hear the thunder. But it could be moving in your direction. If you can see the lightning, you're probably still within striking range, even if it might be several miles away. Things to keep in mind with lightning, lightning strikes the US about 25 million times a year or 100 times per second globally. That is a lot of lightning. And we definitely see a lot of that here. Maybe not as much as like Florida, but we can get a lot here. An average of 29 people per year are killed by lightning. Fortunately, 20 in 2019. Lightning is formed by the rising and descending air within a thunderstorm. So again, as we're talking about those cumulus clouds, those cumulonimbus clouds, that's where you can start seeing those charges build up, lightning start forming. Average lightning bolt has enough energy to power a 100-watt light bulb for over 3 months, just for a scale of power there. Also, the air around lightning strike is around 50,000 degrees Fahrenheit. Again, if these people are getting struck by lightning, they need medical attention immediately. Thunder is just the shock wave that's formed by the rapid heating and cooling of air near a lightning strike. And most lightning deaths and injuries happen when people are caught outdoors, more so in the summer. Lightning does account for over a quarter of all wildfires started on average per year, and no place outside is safe from lightning when thunderstorms are in the area. So if you can hear thunder, you are definitely within lightning striking distance, and it's recommended you stay indoors up to 30 minutes after you hear the last sounds of thunder. So again, talking about the from the blue or bolt from the blue, this is Mike Betts from the Weather channel talking about being aware that lightning can occur outside of a thunderstorm. This one in particular is about 4 miles from the storm near that particular metro area. So this is just one very small example, but it happens all the time. So as far as safety and preparedness stuff goes, even when you're indoors, you should still keep some things in mind. If you can hear thunder or see lightning, don't use corded phones or corded objects like computers, other electrical equipment that puts you in direct contact with electricity via a cable. Avoid plumbing, including sinks, baths, and faucets. Stay away from windows and doors and stay off porches. Do not lie down on concrete floors and do not lean against concrete walls. One, because of the moisture that can be contained within, but then also rebar, which is just basically big lightning rods. If you're completely unable to get indoors away from lightning, which is not a great situation to be in, there are still some tips for maximizing your safety. Immediately get off of elevated areas like hills and buildings, mountain ridges, peaks, that kind of thing. Never lie flat on the ground. Crouch down as low as you can and remain on your feet. Never shelter under an isolated tree. Never use a cliff or rocky overhang for shelter. As it rains, those rocks can get loose. You might end up getting crushed or caught in a mud or rock slide. And then immediately get out of and away from ponds, lakes, and other bodies of water. Stay away from objects that conduct electricity. I feel like those are pretty straightforward, but it occasionally you'll get stuck outside. Just try to do what you can to minimize your safety, or maximize your safety, minimize your threat. Here's some different types of lightning. The most common ones would be these ones that we see usually below the clouds. If you happen to be far enough away from a large storm complex, you might be able to see some of these cool ones up above. If you're very far away, you might even be able to see some of these rare types like the tendrils of sprites and elves. Those are usually very, very high up in the atmosphere, so you usually have to be at quite a great distance. But usually the positive cloud to ground, that kind of spider lightning, and then the negative cloud to ground near the convective core. That's the most common type that you're going to see. Moving away from lightning, we've got straight line winds. It's not so much the wind that'll kill you, but rather what gets caught up in the wind and what the wind throws at you. Straight line winds are pretty much exactly that. They're winds that essentially blow in a single direction. Typically, straight line winds can leave a damage path. Though wider than a tornado, it's usually a bit less extreme to some degree. Wind speeds associated with straight line winds are almost always 100 miles per hour, but there are always those kind of freak scenarios where it might be higher. This picture here is actually from a windstorm we encountered in Independence in June 2015. We had a very strong windstorm that rolled through the area and knocked over some very, very old trees. So you can see a person for scale here kind of on the left side and how big around that trunk was, just for a kind of a scale of how much damage the storm did. And it was just a windstorm. Some of your TV folks might like to be a little bit more cheeky about things and try to keep things a little lighthearted. So sometimes you see them kind of put out their own little like wind forecasts and their kind of scale for that sort of thing. But most of the time, you're just going to hear NWS talk about wind in terms of miles per hour. We've got hail, which is another super common thing with severe thunderstorms we see in our area. Hail and straight line winds generally don't necessarily get the same kind of attention or respect as tornadoes, but they can be just as deadly. Hail can exceed the size of softballs and fall at speeds over 100 miles per hour, which is enough to seriously injure or kill someone in its path. The largest recorded hailstone in U.S. history fell on July 23rd, 2010, in Vivian, South Dakota, measuring 8 inches in diameter, which is, that's a hailstone about as big across as like your face. Damage caused by wind and hail cost State Farm and its policyholders more than $3.9 billion with a B dollars in 2012, according to an April 2013 analysis. And again, that's just wind and hail alone caused that much damage in the U.S. Texas was the state with the most wind and hail losses, followed by Illinois, New York, Ohio, and there's Missouri in the list, Tennessee, Indiana, New Jersey, Kentucky, and Colorado. So again, Missouri, we definitely get our fair share of hail here. There were almost 5,500 major hailstorms in 2013, according to statistics pulled from NOAA's Severe Storms database, with the largest lining up directly with a kind of our hotspot for severe weather months, being May, June, and July. Kind of a neat, simple graphic on how hail works. I find this interesting, but basically the updraft in a storm just takes those little water droplets and raises them high enough up in the atmosphere above the freezing line. They start to freeze and condense. And then all these other little water droplets get stuck together, forming these little hailstones. And it kind of just continues to repeat that process with that updraft as they get caught in that kind of a loop. Eventually, they get so much water frozen to them that they get so heavy, they then just fall from the sky. Seems kind of impressive to me. I don't know. It's kind of a neat mechanic when you think about how hail actually works. Obviously, or at least I would hope to be obvious, never go outside during a hailstorm to try to protect your property. If you do, you risk injury and possibly even death, like we've talked about. If you're on the road, this is probably about the only severe weather threat where I would say it's maybe permissible to seek shelter under an overpass. And we'll talk about underpasses and why it's a bad idea for basically everything else going down the road here. Again, this assumes that there are no high winds at ground level associated with a storm and that hail is your primary threat. But what do you do after a hailstorm? You can then assess the damage, check trees, shrubs, plants around your house. If they're stripped of their foliage, there is a possibility that your roof might be damaged. So you would want to check for roof damage, like if patio covers, screens, or soft aluminum roof vents are dented. If you're not able to check it or you don't feel comfortable doing it, this would be the time to probably call your insurance company, have them come out and check it. Check your car for dents and broken and cracked glass. You don't want to go sit in your car only to find out that you're sitting in a seat full of glass. Protect your property now from further damage. Now that it's safe to go out after this storm, especially if you've got other storms coming in after the fact. Covering those broken windows on your home or your vehicle. And then again, make sure you file your insurance claims or select a repair company. The sooner you get on the ball with that, the sooner you're going to have a turnaround, especially if you're in an area that receives a lot of hail. Your neighbors, and half of your city is going to be calling to get their roofs and cars fixed too. So being one of the first to call is going to save you some time and frustration later. And then if you have to get a new roof, you might check to see if there's a way to have it rebuilt with hail resistive roofing materials. There is a nice chart that you can Google. If you look up hail size comparison chart, this is probably what you should get. So it shows everything from like coin sizes to some different sports balls, even like CD and DVD size. Hopefully you never experience hail that big, but if you find this, you can print it off. It's good to have. Again, wait until after the hail's done, then go out to your yard and kind of collect up a handful, bring it in, set it down, do your comparisons. Whatever the biggest size is what you would report, even if it's only like 1 out of 100 hailstones. If you've got one that's golf ball size and all the rest are quarter, you would report golf ball sized hail. And then we've got flooding, which has been, an issue all over here in the past. The AMS, or the American Meteorological Society's definition of a flash flood, is a flood that rises and falls quite rapidly with little or no advanced warning, usually as the result of intense rainfall over a relatively small area. That's something that we experience here. I know around the city, there's like 3 different locations where, we always kind of have people go check out after a nice heavy rain just to see kind of what the status is. As the little note down the bottom right says here, floods are the #1 natural disaster in the United States. Water is extremely powerful and it's extremely destructive. Whatever it touches that it's not supposed to, basically it can destroy. Flood waters can roll boulders, tear out trees, destroy buildings and bridges. So in the past 5 or 6 years, all 50 states have experienced floods or flash floods to some degree. Homeowners insurance does not cover flood damage. Like 99% of the time, you usually have to get an additional coverage for that. So if you're in an area that's within a flood zone, you might want to have that conversation with whoever your insurance is to make sure that you do get covered. A car can easily be carried away by just 2 feet of rushing water, sometimes less. And just a few inches of rushing water is enough to knock you off your feet and sweep you away. I know it sounds kind of crazy, but you just because you think it's a little bit of water, if it's rushing fast, like it's got a lot of velocity and it can carry you. So besides the preparedness actions that you take with the other, what we consider like all hazards, flooding, of course, would have its own unique challenges when trying to get prepared. So again, if you're in an area that's prone to flooding, make sure that you're protected, but then you can also sign up for notifications. Usually if you contact your local weather service office, they can get you a link or something for the Advanced Hydrologic Predictive Service. Unless you're really in like a really flood prone area, this probably isn't a big deal. But if you do happen to be in that area, or maybe you've got like some agriculture or something that's really prone, this might be a good idea to check into. When preparing your home, make sure you have access to sandbag materials, assuming that you even have time to do so. Again, if you're in a flood area, having this kind of stuff on hand can really save you a lot of time and heartache. Also have plumbers install check valves to prevent floodwaters from backing up into the drains of your home. Test your sump pump and make sure it's in working condition. I have failed to do this in the past and it bit me in the butt. So if you're in the area and we get a nice heavy rain and it comes in through your basement windows, having a sump pump would be helpful in this scenario. So make sure to test it. Be sure to know where your circuit breakers are because you'll want to avoid them if flood waters into your home. I'm in my basement right now. My circuit breaker box is about 10 feet from me. So if my basement were to get moderately flooded, I would not want to come down here. I would just have to leave it alone and call the power company and have them deal with it. And again, make sure you're covered by flood insurance if you're in that kind of an area. It often takes 30 days or more to sign up for that kind of coverage to take effect. It's not for everybody, but if you are in a dangerous area for that, check into it. Something you will definitely hear us talk about on socials and things like that is when flooded, turn around, don't drown. Or more simply, just turn around, don't drown. Don't drive through floodwaters, even if it's a road you take every day. You're like, oh, it's probably just a couple of inches. It's not that big a deal. I mean, we just talked about where it doesn't take a lot to move a car or knock you off your feet or something. Plus, you don't know if the water has, washed out the road. Maybe you're driving along and everything's cool. It's just, 3 or 4 inches of water. And then you go nose down into an 8-foot area where the water's completely washed out the road. That's not a good situation to be in. So call it in, let police block it off. Just let them know where it is. Do not drive through it. Please, please, please don't drive through it. All right. This is the first question break. We've covered kind of just the general severe weather stuff so far and kind of some general preparedness stuff with it. Any questions about what we've covered so far? All right, not seeing any. If you guys think of any, definitely just hit the chat button and let us know. But that's cool. We'll just go ahead and continue on then. So all of these things we've talked about so far don't necessarily have to equate to a severe storm, but once you get to a certain point, then that's when we're talking severe weather. So, while non-severe thunderstorms can be damaging to some degree, like why is it important that we define what severe is? Why not just talk about thunderstorms all in the same way? Like thunderstorm, right? The reason for exact definition is that severe weather is more dangerous. So lines have to be drawn at some point where that threshold begins to start being life-threatening and more damaging across the board. So even within severe weather, it's still important to take note of specifics. For example, tornadoes and hurricanes have multiple classifications denoting a dramatic increase in their threat to life and property. So an Ef3 tornado or a Category 3 hurricane, those types of severe weather, those categorizations, once you get to a 3, that's when it becomes a major tornado or a major hurricane, respectively. Again, as that threat becomes more and more life-threatening, the verbiage around those things also changes, and that's why it's really important. It has been found through social studies and things like that, with the way that the language used determines on how people react to things. So as things ramp up, there has to be kind of an increase in language around those things to get people to act appropriately. So what is severe? That is wind speeds of 58 miles per hour or greater, hail 1 inch in diameter or greater, and a funnel cloud or tornado spotted or radar indicated. It only takes one of these 3 things to constitute a severe storm that will generate a warning. You might have all 3. In fact, especially with really powerful severe storms, you very well will have all 3 of these, but it only takes one out of these 3 to constitute a severe storm warning. Now, back in the day, there used to be just 4 risk zones when you're talking about outlooks and things like that. But since 2011, there have been these additional colors added in. So there's the non-severe, which is the very light green. Then there's marginal, which is the darker green, slight, which is your yellow, enhanced in orange, moderate in the red, and high in the magenta. I don't think they're planning on really changing that anytime soon, but if you happen to be looking at outlooks, these types of graphics are shared, usually a bit more localized, but you will see these put out by weather service offices, by the Storm Prediction Center. Emergency managers might take these graphics and put them out. Local broadcast TV. Now, I will say local broadcast TV here in our area has done a good job, for the most part, unifying the colors they use on TV with the official National Weather Service and the Storm Prediction Center colors. That's not always the case. If you're not from the Kansas City area, it may be completely different. And that's their right to do so, but it does cause confusion. So just be very aware of those things. Just to break those colors down a little bit more, like I said, there's the general thunderstorm or the non-severe, which, you're talking about like winds of 40 miles an hour, maybe some small hail. But then you get into like your greater risks. So you start seeing more wind, bigger hail, And as you move up the chain here, then you start talking also about damage. So you've got significant damage, significant damage. Then you get to a point where, you know, things are more and more likely. The damage possibility is greater, the risk to life is greater, and you usually have much larger stats, like more than like a single tornado on the ground. There might be several tornadoes or a tornado outbreak, or maybe it's a derecho event. There might be like long periods of high winds, very large hail, those types of things. So when you take all of these things and kind of put them together, when they put this data in, it spits out these kind of color codes to let us know, like, this is what our thinking is for the day. So again, that is what we would call the outlook. That's the real kind of general, like, here's what our thinking is. Here's where the greatest risk is, and these are kind of the time frames that we're looking at. Versus a watch, which is the, hey, once we get to this time frame, between this time frame and this time frame, you know, start thinking of preparedness actions. Like, go ahead and start like doing what you need to prepare if we get to a warning. And then there's the warning, which is now you take action for sure. The warning is you need to act now. You need to do the preparedness action appropriate for this event. Then we've got things like the difference between county-based warnings, which is the red box here, the squiggle for this county, versus a polygon storm-based warning. County-based are still pretty common, but it's a larger area that covers an entire county, which leads to a larger false alarm area and potentially more people warned than may be necessary. Versus a polygon storm-based warning, which is more focused. It's a smaller area warned, a smaller false alarm area, and fewer people are warned unnecessarily. So weather radios and things like that, a lot of verbiage. The automated systems still key off on these the older county-based warnings, but with phone apps and better understanding for how to get things to recognize these polygons, they are much more accurate in who needs to kind of follow that information. So good just to kind of know the difference between those two. Here's another example of a polygon warning. This is a graphic you might see like NWS Tornado account put out, or a local emergency manager might grab this from NWS or something like that. But it's real easy to determine. You know, here's the shape, here's the area, that if you're within this colored area, here's what to expect: tornado, radar indicated tornado, and then hail up to like $half size possible. There's some other indications as to like population, schools, and things like that, but primarily it's the, this is where it is, this is where it's going to happen, and these are the things that are happening, and here's the timestamp for it. That's all the warning system is there for. So there are 4 major ingredients to understanding severe storms, and that's shear, lift, instability, and moisture. Shear is that kind of local variation or the wind vector. Basically, the wind given in a direction based on its altitude. We'll talk about a little bit more of all these here in the next few slides. Lift is like, you know, when you've got the temperature fronts, they move through the atmosphere and the winds kind of blow up or down, kind of like rolling hills and mountains, or when the winds blow in from the ocean. These kind of things can create lift. Then there's the instability in the air, which is what can lead to those up and down drafts. Basically, the air creates these drafts when it's trying to balance itself out. So if things are really unstable in like a low pressure system, it's trying to regulate that, and that's where you get those up and down drafts. And then moisture, probably the most common one. It's what makes clouds and rain and things like that. But that is the prime component for creating the clouds and rain. And then once you get clouds, again, with these up and down drafts, you've got these molecules bouncing off each other, rubbing against each other. You start getting charge built up and lightning and things like that. So thunderstorms can be isolated, which would be a single cell storm, in clusters and also in lines. Typically speaking, In our area, we've got clusters and line type storms. I'd say a pretty good chunk of the time. The only time you might see a single cell storm is if you happen to be right where one is starting to take off, what we call like the initiation zone. But primarily in our area, I think lines and clusters are pretty much the norm. Thunderstorms often produce heavy rain, ranging from 30 minutes to an hour, sometimes longer. An interesting thing to note is that only about 10% of all thunderstorms are classified as severe. So that again, it produces 1-inch hail, has winds of 58 miles an hour or greater, or produces a tornado or foam cloud. Then, while it's not necessarily one of the 4 things that make up a storm, there is dew point. So this is a funny graphic that Channel 5 put out talking about dew point and what it does to your hair. I know my wife can attest to this. But basically, the dew point is an important thing to track because it directly correlates to cloud formation. Because it has to do with how saturated the air can get before it starts condensating. So typically, the best storm conditions begin to develop when that dew point kind of pushes beyond 68 degrees. So that's not like 68 degrees Fahrenheit. That's the dew point of 68 degrees. So if you happen to be a person that notices when they're talking about this, that, and the other thing, but they mention the dew point, pay attention, because usually that about that 68 degrees is really where you start in dew point getting into the development of severe thunderstorms and things like that. I know it's a little bit of a general rule of thumb, but keep note of that as we get into spring and summer. And as you've seen already, obviously, moisture and clouds play a huge part in severe thunderstorms and tornadoes. So going back to shear. So again, that's the wind speed at certain levels of the atmosphere. And usually as you go up in height in the atmosphere, the winds become greater and greater and are at slightly different directions. So this one helps with the lift process and also helps with the beginning of vortices or spins and things like that within storms. And as you look at this particular graphic here, you can see that this storm has that kind of tilt to it because that wind aloft is so much heavier. It's tilting this column of clouds to one side, known as a tilted updraft. And if you look closely, I know it's not a super great quality graphic, but you can almost see that you can almost visualize that spinning of that tilted updraft. It's leaning and it's kind of smoothed out a little bit. So this is a picture I took. You can see it a little bit better here. I've enhanced it a little bit to see, but this is something I saw when I walked out in my front yard a couple summers ago. And on radar, this thing looked pretty bad. And I wanted to get eyes on it because radar can only see so much. And I saw this and I called the EOC. I said, guys, like, we very well may need to sound the sirens on this. I can't guarantee that it's putting down a tornado, but it's got all the telltale signs otherwise. I couldn't see anything all the way down at the cloud deck because there's a big column of rain down here. But just looking at this cloud, you can see the tilt. You can see it tilting from left to right here, from south to north. This thing was almost heading due north. And you can see these kind of striations, these lines around it. So again, you can almost visualize that twisting nature, almost like the wind is kind of wringing out that column of clouds. And so when you get that kind of a spin and these big clouds, that's a very indicative, like a big up and down draft and that shear coming into play. That's usually associated with localized low pressure, essentially the heart of the storm itself. Some such thunderstorms can feature strong surface winds and severe hail. It was pretty windy at my location. I actually wasn't getting any rain. So at my area, it was very low precipitation, but then right underneath this storm, it was like complete like blackout conditions as far as the amount of rain coming out of it. Mesocyclones or the whole system rotation are often coupled with updrafts and supercells within which, again, tornadoes might form, which is why this was very concerning when I walked out of my yard and I saw this. I thought, I can't tell from where I'm at, but it's very possible there might be a tornado associated here. So on the flip side of that coin, this might initially look like a tornado to the uninitiated, but in fact, it is what we call a Scud Cloud, which stands for scattered cumulus under deck, which is just, underneath the cloud deck, this kind of scattered look. Again, let me roll back. So let's see, kind of scattered, kind of a shotgun, it's kind of all over the place. It is sort of attached to the clouds that are kind of low to the ground. It looks a little tornadic, maybe. It's got kind of that shape, but really behind these trees, it's not in contact with the ground, and it's also not rotating, which is why it's got that jagged appearance. If this were a funnel cloud or a tornado, those winds in a vortice or a vortex would be smoothing off those edges. So you might see this and it may kind of be moving with the cloud, but there's no rotation on this thing whatsoever. And that's basically what a scud or a scary looking cloud, as we a lot of times we refer to, looks like. And at a distance, this can be really hard to tell. So it might take a second, for you, like if you're out observing and you see this, you might have to kind of sit there, as long as you're not in danger's way. If you see this thing, you're like, is it spinning? No, no, it's not spinning. And it might take you a minute to kind of, at a distance, really get a good feel for what it is. But just make sure that, that's all part of being a spotter and being weather aware, is actually like taking a second to observe and realize what you're looking at. Then this is a computer generated graphic of a very classic supercell. So kind of a lot of things that we've talked about so far. You've got your rain or hail down here in the dark area. You got your little wall cloud, which we'll cover here in a sec, and a tornado. And this is fairly comparable to, this would be like a small tornado with the total size of maybe the supercell that we're looking at here. So, you've got your big cumulonimbus cloud that's towered all the way up. There's that anvil shape. And then at the top, it's an overshooting top. And I like to equate that to kind of the older coffee makers with like a percolator at the top. It's just, that warm air is bubbling all that moisture up until it like spills over the top of this cloud. Essentially, that's all that's happening here. And that's usually where that big updraft is. And then the tornado would be kind of where that downdraft is. And with the shear, you get the kind of that tilt of the system. So all those things, like if you're far enough away and you can see this kind of isolated storm, this is roughly what it would look like. So here is then, yes, this is an actual picture, not mine. Credit to this Eric Helgeson. I just found this on Twitter. But this is what a real life full-size mature thunderstorm would look like at a great distance. So again, you can kind of get all those details. There's rain and hail back here. I don't see a tornado, but it does look like maybe there's a little bit of a wall cloud here. It's very hard to tell because this is very late in the afternoon. But you've got your cumulonimbus clouds, you've got that tilt, and then you've got that big anvil at the top. Probably not far enough away to see an overshooting top at this point, but when you see an image like this, you are looking at a very mature thunderstorm. And generally speaking, whatever way that kind of anvil is pointing, if it could point, that's generally what way this massive storm is heading. So it kind of gives you kind of a pretty good heads up as to, what direction this thing's going and sort of what to expect. So what I was just saying, anvil clouds, it's named for that telltale flat top of a thunderstorm, like old school anvils. They are massive cumulonimbus clouds that can cover hundreds of miles out from the main thunderstorm itself. Once that moisture gets high enough up in the atmosphere, it may hit like a jet stream or something. So it's just really going to spread that cloud deck out across a long distance. And lightning can strike from those anvil clouds, even the parts that might be way out in front of that main storm complex. So again, that might be what people call the like out of the blue lightning strikes. So if you see an anvil cloud, again, know that it's a very major thunderstorm. You definitely should be checking the weather at that point. Also consider yourself lucky. If you're far enough away to see something like that, try to get a picture. It's hard to be at the right distance with the right weather setup to be able to see all that. Usually it's kind of nested behind a bunch of rain and crud. It's a pretty cool sight to behold. As long as you're safe. There's also shelf clouds, so that's a feature that's usually on the front leading edge of a storm, but this is also an indicator that you've got a pretty mature storm on your hands here. So you're usually much, much closer, but so you might not be able to see necessarily that anvil on top, or it just looks like cloud cover at that point. So you're much closer, but you still kind of get these interesting kind of striations in the cloud. It's very angled as these two air masses start to butt up against each other. So you get this kind of rubbing effect on the front. Kind of looks like the cow catchers on the front of trains of old. So imagine like the wind as it hits the front of, you know, the old part, the trains like that, and it just sort of grinds on it like that. That's basically what's happening here. So you've got this colder air mass hitting this warm air mass, and so you've got the shelving that happens. This is the underneath side of what a shelf cloud looks like as it goes over the top of you. So this is, again, going back here, as this front edge goes past you and you get just underneath, like into that kind of dark part, the sky dramatically changes. It looks like the under part of like a wave on the ocean. If you've ever seen like Nat Geo or something where they take a camera into a big wave, it looks very, very similar. And that's basically what's happening here. You've got these two air masses that are acting kind of like a wave and the air around the wave. It's liquid dynamics in a big scale here. So again, you get the wave kind of formation, and then you also immediately will notice the temperature will drop, the winds will pick up, and you'll probably start seeing like rain, hail, anything that might be associated with a severe thunderstorm at this point. If you're in this position, this is your, I need to get back in my vehicle and stop taking pictures at this point if you haven't already. So again, shelf clouds themselves, the outer edges, they're found on the leading edges of like a gust front or like an outflow boundary from a thunderstorm, or strong winds flowing down and outward from a storm. The outer parts of a shelf cloud are usually really smooth, with pretty visible like rising motion, and sometimes can be in tiers, hence shelves or shelf clouds. In this case, the underneath, like we were just looking at, that appearance is usually a lot different. It's much more turbulent looking because this is all the rest of the air that didn't end up on the front side of that cloud. Now it's the air that's getting rolled over. Imagine like if you were like laying on the ground and like a large semi truck like drove over the top of you, how that air would be really turbulent underneath a truck. That's basically what's going on here. So this is this big storm just rolling over, and this is the air that's left to kind of roll underneath. Because of the strong winds associated with the formation of shelf clouds, like I said, expect strong or damaging winds as that leading edge rolls over your location. Definitely try to seek shelter indoors, if not at least in your vehicle. And after that leading edge goes by, you can expect any of the other modes of severe thunderstorm to basically happen after that point. Now, this is different, and I said we would get into this. This is different than a burst event, which is a little, it doesn't quite line up the same way. The AMS definition of a downburst is an area of strong, often damaging winds produced by one or more convective downdrafts. It's a very fancy way of saying a whole lot of air up above can no longer be supported, and literally this like ball of air falls to the ground. So, you think of like the size of a thunderstorm, how big these things are. Well, if all of that energy comes down and basically like hits the ground from that central point, it's just going to kind of blow outward, kind of like a slow bomb almost. And then there's a little bit further definition. There's a microburst, which is the same thing, but it covers an area less than 4 kilometers along a side with peak winds that last 2 to 5 minutes. Versus a macro burst, which is again a downburst, but it covers an area greater than 4 kilometers along the side with peak winds often associated with bow echoes. Sometimes you see those with derecho events where maybe a part of a thunderstorm gets out ahead of the rest and then there's nothing to support it, so it collapses. Burst events are very unpredictable. There's not like, you're never going to see like a downburst watch or something like that. Like there's just not a way to predict it at this point. So, if it happens, you can really be taken off guard. It can be scary. It might feel like a straight line wind event, but the mechanics behind it are very different. And you'll see here in just a minute. Ideally, you'd already be inside taking shelter from the storm, but you know, if you're caught outdoors, you want to try to take cover in some form or fashion immediately. And usually, your only indication is one, if it's sunny outside, or at least you know there's enough light, you can almost see this like ball. It almost just looks like a ball of rain all come down at once, and then it just sort of like squishes. Imagine if you watch slow motion, a water balloon hit the ground and start squeezing out, and then it just explodes outward. That's basically what a downburst is. So you've got all this wind just all at once rushing out from the central point. Do not, do not take shelter underneath an overpass for a wind event. Overpasses can funnel winds and actually increase wind speeds because it's being forced through a narrower area. So again, yeah, this tip also applies to straight line winds and tornadoes because those are wind-based events. So then sometimes you can get a multi-burst event, which we had here. July 22nd, a couple years ago, around 10 p.m., we had just these kind of not super big thunderstorms kind of roll in one behind each other. Well, let me just play it here and you'll see. This is velocity. So you can see it kind of, these bubbles just sort of burst in different areas. I mean, you can see the winds bubble out from one location. I'll play this again. You can see it pops here and out here. That's almost as if you dropped like 3 big drops into the water, how you get those kind of rings. That's what happened here. So these storms were coming in from Kansas, and they got to a certain point where they no longer had an updraft for whatever reason. Maybe there was like a little dry air socket or something. But essentially the thunderstorm was trucking along, and then it got cut off from its up air supply. And so it literally just fell out of the sky. And it just sort of caused this like chain reaction where we had multiple bursts in a very short period of time. And it ended up causing quite a bit of damage. The biggest one caused about 70-mile-an-hour winds in the downtown area, or down Kansas City proper. And it left over 100,000 people in the greater metro area without power immediately following this weather event. So what went from basically some non-severe thunderstorms that just happened to be big enough, they all fell out of the sky short one after the other and caused a lot of damage from all that wind that was left over. So here is a wall cloud. So there's the cloud deck itself, but then there's this lowering of the cloud deck. And hopefully you can see on your screen, but you can kind of see like these striations, these stripes, or kind of a corkscrewing as it goes around here. And that's because this whole system is spinning. And so as these winds spin like this, that's what gives you that. I mean, you can almost visualize the still image spinning. So as you have the cloud deck, if you get a lowering, that's a wall cloud. And that is usually a pretty good indicator of a developing thunderstorm. It's probably approaching maturity at this point. Wall clouds can form when rapidly rising air causes a lowering of pressure below the thunderstorm's main updraft. And that's a very important feature to keep your eyes on. Wall clouds can range from a fraction of a mile up to nearly 5 miles in diameter. Kind of depends on all the dynamics at play. But if you notice a wall cloud, you should probably try to observe its direction and speed so that you don't end up underneath one. Because a wall cloud can quickly go to a funnel cloud or a tornado. Wall clouds, you know, they often have some rotation, so they're already pretty primed to do this. And that rotation can be an indication that a tornado will touch down. But, you know, there's no way to tell for sure. So you really have to kind of keep an eye on it for that funnel or tornadic development. And your first indication might not even be a visible cone. You might just start seeing down below this lowering, you might just start seeing like dust and stuff kind of getting kicked up. So there's still the wind there. You just don't see the cone until there's enough dust or moisture in place. So very important to keep an eye on. Hopefully it gives you something like this before it starts interacting with the ground. There's a funnel cloud. So it's just exactly that. It's a funnel shaped cloud. It's just a rotating column of air. But the reason we see them is because of the visible condensation. And you don't always see them. And sometimes, like I said, it might just be the dust that you see first before you even see the condensation happen. The one distinct difference between a funnel cloud and a tornado is that the tornado actually touches the ground. So once a funnel cloud reaches the ground, it is then a tornado. For all intents and purposes, funnel clouds should be treated with the exact same urgency as a tornado, as they could touch down at any moment. So if you're out observing this, you see a funnel cloud, call it in. That would be call it in the National Weather Service. Say, I see a funnel cloud. This is where I'm at. This is kind of what direction it's heading. This is about how far it is from me. They'll put out that warning. Versus a tornado, I was about maybe a third of a mile from this Ef2 down in Oklahoma. But this is a pretty long-lived, kind of slow. It was slow moving at first, but I tell you what, it really picked up speed once it got on the ground. Which I'm just glad I was a little bit far enough south to be out of danger's way on this one. But again, tornadoes are like funnel clouds. It's a rotating column of air with visible cone of condensation. It's just that it is in contact with the ground. All manner and shapes and sizes can be seen with tornadoes, from those little wispy rope-like we saw in the funnel cloud. They might be stovepipe, like just very like a column, wedge-shaped, maybe even so big you can't even tell that it's there. It takes up your whole vision. Some are very vertical and some can be very horizontal. It really depends on all the different factors that are taking place. The most intense tornadoes are definitely going to be the wedge tornadoes. And sometimes, like I said, those wedge tornadoes can't even be discerned as a tornado. You may be so close to such a large tornado. It's just a bunch of wind and rain, and you can't really tell what's going on. It just looks like a hot mess of terror, which is a lot like what the big one out by the racetrack looked like a couple summers ago. I got a bit too close to that one, started registering about 90, 100 mile an hour winds, even though I was still like a mile from it. I was trying to spot this thing. I'm like, I can't see it. I just see like there's debris, there's rain. I'm measuring really high wind speeds. I'm like, it's time for me to bail. I can't see this thing anymore. I'm way too close. So oftentimes with these things, you can get that kind of freight train noise that you hear a lot of people talk about because of those intensely rotating winds. There's just so much wind. It's incredibly loud, make your ears pop. Tornadoes are also often accompanied by like I said, the massive pressure drop that it can cause your ears to pop. It might be very painful at times, depending on how close you are. And again, if you see a funnel cloud or a tornado, make sure you're seeking shelter immediately. You're like trying to get out of the way. So next question break here. Yes, a waterfall type noise. That's also a good way to describe that. Anything we covered so far that anybody's got any questions on? Oh, all right. You guys just trucking then. Also, I appreciate you guys bearing with me. I know my throat is kind of giving out. I've never done a double header in the same day before with this class. So I'm going to truck through this though. We're going to get there. If you can't tell, I really like weather. So this is fun. This is fun.
It's the best.
This is the kind of stuff I live for. So, all right. So now we're going to we've really kind of differentiated between all the things. So I want to kind of talk a little bit more. We'll start diving down a little bit more granular here. Again, the AMS definition, a tornado, it's just a rotating column of air in contact with the surface. It's a very dry definition. It doesn't sound very scary, but I tell you what, if you get close enough to a tornado, you're like, I feel like it's a bit more than just a rotating column of air in contact with the surface, but that is the definition. So we're going to get into the intensity of these things. It's often estimated based on both wind speed and damage to structures. The old system was just wind speed strictly, but it was felt like, especially with like the advent of like emergency management and things like that, and needing to differentiate like the raw damage output of these things wasn't necessarily attributed just to the wind. So we now have the enhanced Fujita scale, the EF scale that you hear of, which is the wind and damage kind of paired together. And it's named after Tetsuya Theodore, or Ted Fujita. He was very prominent in severe storms research. He worked on understanding like thunderstorms and tornadoes and hurricanes and typhoons. That's his entire life work. That's basically all he did, and he was amazing with it. Some tornadoes may have other vortices. So you've got one tornado, and then it's got other little tornadoes around it. So if you go back and look up like Pilgrim, Nebraska, that was a very extreme case where you had like, was it an Ef2 and an Ef3 within like quarter mile of each other? It was nuts. It was not. That's a very extreme case, but with very large tornadoes, it isn't entirely uncommon to have very small, like minor or sub vortices around them, just because there's so much wind happening that the air is just trying its best to equalize. Tornadoes have been recorded on every continent in the world, excluding Antarctica. A vast majority of those do actually happen in the US, almost 1,000 per year on average. Tornadoes can happen, I know I mentioned this earlier, but any time of year, anytime, day and night. Obviously, conditions have to be right for it, but it can and will happen any time of year, day or night. So that EF scale I mentioned, out of the entire scale, it goes from EF0 to EF5, but 83% of those are in that low range between EF0 and EF1. And that's not to say that they're not dangerous, because a tornado is very dangerous. Even at a low grade, you're talking 65-mile-an-hour winds. Whereas then you bump it up to an EF1. So on the high side of an EF1, you're talking 110 miles an hour. That's pretty fast. I don't know if you've ever driven 110 miles an hour. It's fast. Fortunately, these storms are short-lived, kind of short-tracked. They can occur in non-supercells, so they can be a little bit more freak, I guess. Then you've got Ef2s and Ef3s. So this is where you go from like kind of the strong end of the low side to the beginning of what's considered a major tornado at Ef3. So you've got 111 to 165 miles per hour. These are a little bit longer track, a little bit longer duration, and they are almost always associated with supercells. Again, these are paired with damage. So on the right here, you can kind of see the damage associated with these things. The EF4, EF5, that's well into major tornado classification. And fortunately, those are less than 1% of all tornadoes. Though, with climate change and things like that, we are starting to see kind of a bit of an uptick of maybe fewer tornadoes, but more stronger tornadoes. So these stats are going to start to kind of get a little bit more lopsided, unfortunately. And that's 166 to 200 plus mile an hours. Sometimes these monsters can be on the ground for hours at a time, tearing up all kinds of things. They develop from very well organized supercell thunderstorms. And here is each one classified with just the amount of wind and damage here. But this is a better visual. So, on this northwest side of this neighborhood, it's got EF0 damage, which is hard to tell, but basically there's some maybe like shingles and stuff, maybe kind of tore off here and there, little patches of just the wood exposed underneath the shingle. Nothing crazy. EF1, you're talking, maybe a little bit of damage to some roofs that might have been on like the wind facing side. If you got maybe like the flat side of like a gable roof or something. Then you move on to like the EF2, and you're starting to look at pretty major roof damage, but the walls for the most part are still intact. And then you move on to the EF3. Again, this is why these definitions and why we are so specific with these types of classifications exist. Once you go from EF2 to EF3, with at least the way houses primarily are built right now, once you go into that EF3 range, it really starts making a major case for damage here. You go from, maybe one wall with damage and some kind of major roof damage to now you're looking at, you might have an interior, like a reinforced interior room left. That might be about, you might have like some partial walls, but for the most part, like the house is no longer recognizable. It is a pile of debris with maybe like your middle bathroom intact. Then you get to EF4, which is, there's not even a semblance of a structure left. It's basically just debris scattered everywhere. And that's it. EF5s are, now you're talking the entire structure itself has been blown completely off of its foundation. All you're left with is concrete slabs. One thing I failed to mention in our AM class is that when you see tornado damage in person, you can see pictures like this, you can see live news coverage. Until you see it in person, you just don't have a real idea. It's just different. I don't know how to describe. There's not really a way to describe it. I don't mean to be overly dramatic about it, but like seeing that level of damage in person can be very impactful on like a mental and an emotional level. I know I just happened to drive through Joplin about 2 weeks after it happened, and seeing, enormous trees like you see up here. It's Missouri. There's a lot of old big trees and things like that. Seeing literally just like the nub of a trunk left with an SUV wrapped around it, like the outside of like a candy wrapper, and to see just like nothing left but just concrete slabs. Like there's not even like the debris for the house. The debris for the house is gone. So it's, there's no road. The asphalt's been ripped up, chucked somewhere. There's no grass. It's concrete slabs, and just there's no bark on whatever bits of trees are left. It's barkless with just vehicles just mangled and wrapped around it, 15, 20 feet in the air. It's unbelievable. So again, this is why these types of classifications are very important. Now, granted, you only get the EF evaluation after the fact, but again, when people are talking about, these level of winds, you can then start to associate, okay, well, if this level of wind were to hit my neighborhood, what's that going to look like? And that gives you kind of an accurate shot here as to what that looks like. So, sidebar, like we talked about with hail, if you were to report this type of damage and you report the highest, even if it's only one out of all of them, whatever the biggest or highest one is, that's what gets reported. So this storm, even though a lot of it's like EF0, EF1, EF2, there's only a couple of these houses with the EF5 damage. It's going to be recorded as an EF5 storm. So just as a point of reference, that's not saying that everything that's damaged was damaged at an EF5 level. It's just saying that that was the peak experienced. If that makes sense. Okay. So one very important to take away, this slide with the last slide that we were looking at is, so, we talked about tornadoes being a cone of condensated air, basically a cone cloud. But even though that's where the strongest winds are, you can still have very damaging tornadic level winds at a great distance out from that. So these blue lines here show where the tornado actually is, the actual cone, but then those red lines show you where the damaging winds. So let's say if this is an EF5 in the center where the cone is, it tapers off from EF5 to EF4, EF3, EF2, EF1, EF0 as you get further and further out. So you really have to keep that in mind with, as these things ramp up in strength, even though you'll see the cone, like I know it's hard to not focus on the cone, but you've got to know that those damaging winds can be much, much greater in an area than the condensation itself. And that is extremely important if you're out in the field for this type of thing. During a tornado, I would hope that it's very obvious. You need to go to a safe location away from windows on the lowest level of a sturdy building. So, schools still have drills and things like this. This is a good way to cover yourself up. against a reinforced wall or something, an interior area. If you are caught outside, get in the car, buckle up. If you've got the time to drive out of the way, that might be an option. If you can drive yourself to a storm shelter or get home from the store, as long as you've got the time to do it, that might be a lot better than being stuck in like the big box store or something like that. Or go to a storm shelter. Maybe you're in a mobile home, or maybe you're in a park or something like that. And you're not near, a place where you can actually just like in a few steps get to a safe area. So I know like here in Independence, we've got a couple of storm shelters at a couple of the major parks. So it's very important to know where these things are. Excuse me. And before I kind of break into kind of a side tangent, I want to talk a little bit more about tornado safe places. Riding out a tornado does not mean you're always in the best place. Even if you've planned everything to a T, even if you're being very weather aware, sometimes weather will just surprise you. So you're like, it's cool. Like I'm over here, I'm out of the way. But what you don't know is that some slight dynamic changed. And now what was going to be a tornado 10 miles to your north is now going to be a tornadic system right on top of you. It does happen. And so as the graphic on the right here shows, being in a mobile home or a vehicle is definitely not advised. That being said, if you're in a mobile home park, check to see if there is a shelter. Maybe there's like a clubhouse or like a community space or something like that with a reinforced basement that maybe, people can gather in. Or maybe in a nearby park, like I said, like here in Independence, we've got a couple of designated storm shelters for the community that we unlock remotely for people to just pile in once we set off the sirens and things like that. If you are stuck in your car, like I said, driving away might be an option if you've got the time to do it. Otherwise, if it's right on top of you, your best bet might be to stay buckled in, kick your seat back as far as you can go to try and get below that window level so that as your windows blow out, you're not getting shards of glass in the face. Try to stay buckled in, kick that seat back as far as you can go, cover your face and like your soft spots if you can, protecting your head. And that might be what gets you through. It's not a good place. It's a scary place to be in, but the reality is at least you're doing what you can given the situation. So again, this is why it is absolutely imperative to stay as weather aware as you can, to avoid these types of situations. So I know last class, Pete and I kind of took a side tangent here for a minute to talk about, we've talked about some scenarios here, but one of the hardest mindsets to get in is to kind of like run your brain through these scenarios no matter where you are. So like the next time you're like on your way to work or on your way to the grocery store, think about like at like every like cross street or whatever, like as you're going, like if I were at this particular spot and this is when I needed to take an action, what are my options right here? If once you get to the store, once you get to work, okay, now that I'm inside this building, once I'm at my office, what are my options here? And that's not to be like doom and gloom, like, oh my God, you have to live in a state of panic, but rather to just think through yourself, just, 30 seconds, a minute, maybe 2 minutes, just as you're like, getting your coffee in the morning at the office or, picking up your produce from the grocery store. Like, okay, if I was here and the tornado sirens went off, what am I going to do? What are my options? And run through some of those scenarios in your head. You might not know that your store has a safe room or something like that. So make it a point maybe the next time when you're at the store to go talk to customer service and be like, hey, like what's the tornado plan here? Just so you know, my wife's at Target several times a week, let's say. And she knows that there is a safe room. I think it's up towards the front, and there's also one in the back. It's not like marked or anything, but there's like one of those little maps that's posted somewhere out of like off the beaten path. You have to like know where this plaque is to even see what the like little emergency route within the store and what rooms there are. But knowing that ahead of time, just being like, oh, okay, well, if I'm in the back of the store, I go here. If I'm like checking out, I'm going to just run up here. That saves you so much time in the moment when every second can be critical. So again, that's not to like put terror in you or anything. It's a good mental exercise as you're going from place to place to think about those kinds of things. Take a little bit of initiative, go ask somebody and just be like, hey, what's your plan? They might not have a plan. That's a very real thing. They might be like, we don't know. Put your head between your legs and kiss your butt goodbye. Like they don't have a plan. Unfortunately, that's the reality. So one of the things that I really want everybody to take away, and I know we're only a bit into this, but make sure that you do what little you need to do to at least have a plan for yourself. I digress. We will cover more into that later. So when it comes to severe weather, as long as you are understanding these risks, you should be able to plan accordingly. But when you don't have a plan, all you can do is, as Ray Arnold from Jurassic Park would say, is hold on to your butts. That's about all you can do at that stage. If you don't have a plan, what else are you going to do, right? So start getting that mindset. That's why we do these classes, especially before storm season. It's good to start thinking about these things just a little bit at a time. It doesn't have to be overwhelming. So we will go into our radar section. Again, some of you might be like super familiar with this. This is old hat, whatever. Take a coffee break maybe for the next like 15 minutes or something. But for those that don't know this stuff, feel free to ask questions. Now more than ever throughout the rest of the presentation, if you've got a question, hammer at us in chat. I want to stop as we've got questions to make sure that we're covering this stuff if you've got any questions. So radar images can be confusing, which I understand, especially if you've got no prior background in weather. James Spann, one of my weather icons, says most people often equate looking at radar images with looking at a bucket of spilled paint. So with this little section, we hope to just fix that a little bit. The goal here is to help you better understand what you're seeing on TV and social media and websites and on smartphone apps, similar to, like we've talked about, when you're out and about and you see clouds. Like, what are the clouds telling you? This is the same thing. If you've got an app and you have access to radar, that can be super helpful, but you got to know what you're looking at. So that way, as you know what you're looking at, then you can take proper preparedness actions. Just a quick little history. Radar is radio detection and ranging. It's a little acronym. Weather radar was developed in World War II for the initial purpose of trying to track warplanes in rain and thunderstorms. So kind of get where we're going here. Observers noticed that their targets were obscured by the rain, leading to additional developments in radar technology. So military and meteorologists began using radar to better forecast weather in the 1950s. And in a nutshell, it's really the same technology that we use today. Obviously, it looks a lot different. There's been a lot more advancements with it, but in a nutshell, it works exactly the same that it has since its inception. We have a lot of sites around the nation, radar sites, with different levels of coverage. Ours here is KEAX. That is its radio call. But one thing that I want you to really notice here is that even in the highly covered areas, it's really looking at its base at 4,000 feet in the air. Now, that's just a bit of an average. But how much weather happens underneath that 4,000 feet? A lot. This is why being a spotter is incredibly important and very helpful to National Weather Service, broadcast meteorologists, and emergency managers. That's why me and Pete do what we do. We kind of literally fill in that gap from where the radar sees to the ground. So, radar might pick up a rotation up here, but what's happening underneath that? Maybe nothing. Maybe it's a freaking tornado on the ground tearing up part of town. There's not a way to really tell that with radar. So I just want you to be aware that what you're seeing on radar is a very small portion of what's really going on. Not saying it's not helpful, because it is. It can be very life-saving, but it has its limitations. So to that end, radar equipment makes multiple passes at different elevations. So one rotation is at one layer, and then it moves up a little bit, and then it makes another rotation. It just kind of does this, but it takes a while. It has to slowly spin to really get a solid look at everything that's going on. And so every time it rotates, it goes up, it goes up, it goes up. It takes a while. So depending on what mode radar sight is running in, it has kind of some different methods for its scanning. It's got what's called AV set, and that's the mode that scans from the bottom to the top, creating one entire composite picture. That's what's considered like a normal scan pattern. And it takes, it may take 7, 8, 9, 10 minutes in some cases, depending on what's going on, to get all of those rotations to hit every single increment to stitch together that picture. So even though you get this nice composite, that's already out of date at this point. So they introduced this mode called sales, which I don't remember what it stands for, but in a nutshell, it's a very rapid scan that only features the lower altitudes. And the reason for that is it does occasionally, it'll do a couple spins where it picks up one or two of the upper layers, but for the most part, it's really focusing lower down. And that is to, excuse me, keep tabs on those lower elevations where like National Weather Service and Storm Prediction Center monitor for those cyclonic rotations, those mesocyclone rotations. So like if weather's moving in, they'll probably switch to this mode to really get focused in on the more important part of the big picture, which also saves time on the back end because they can more rapidly put out information that's helpful. So again, very simplistically, radar in a nutshell, it emits a pulse of electromagnetic energy out, that's what's called the radar beam. But then that once it hits an object, it comes back, and then that's where we get the term reflectivity mode. So the signal goes out, comes back, it's reflected back, and it says, oh, there's a raindrop out there, or there's a hailstone out there. And it does this in, for the most part, a 360 degrees scape.
Question in chat here, Justin,
Yeah.
asking about the better radar apps to go with.
Well, first of all, let me say I'm not sponsored by anybody, but I will say my personal preference for a radar app is Radar Scope. There's another one called like Storm Radar by the Weather Channel. It does a pretty good job for a free app. Radar Scope is a paid app, and that's what I use. I know it's something that our EOC uses for monitoring radar imagery during operations as well.
I think there's another one that's similar to Radar Scope called Pickle 3, if I recall correctly.
That's like pickle, but without an E, it's a 3 on the end or something like that.
Yeah, it's something along those lines. I've used that one before. That one's pretty good, but at the same time, I found that Radar Scope is usually the best one, the easiest one to work with. There's another one that's kind of up and coming that I've seen called Radar Omega, and it's fairly good as well too. I've seen a couple of weird things occur with it that didn't make it terrible, but I still find Radar Scope to be the best one to go with in my own personal opinion.
So, and yeah, if you've got questions or you want us to talk to you more direct about that, just message us on like Facebook or something after class. We'd be happy to talk ad nauseum about using radar apps and things like that. But I know I'll talk about a little bit later. There's a million different apps out there. So, download 2, 3, 4 of them, try them out. Like look at one, open up another one, see what it looks like, kind of, do compare contrast. It's free market. So, download as many as you want. Just make sure you get rid of them if you're not going to use them. Otherwise you're eating up a bunch of space and you're getting a million notifications on your phone. That's way overwhelming. But anyway, yeah, shop around, man. There's a ton of great apps out there. It really kind of depends on what works for you. And that's the cool thing about kind of where we're at with technology and being able to do things with radar data and stuff like that. So yeah, definitely shop around. I personally will always probably, unless I find something that's dramatically better, Radar Scope's kind of my end all be all.
Yeah, I agree.
With the weather, the storm radar from Weather Channel being a really good free one on the side. Okay, so anyway, yeah, the reflectivity mode here, the beam again, it goes out, comes back. That's reflectivity. Think of it kind of like a ping on a submarine, how it sends out a signal and that sound wave comes back. This is not necessarily a sound wave, but it's essentially the same effect. Works very similarly. Then there was the advent of what's called dual polarization, which literally is two beams instead of one beam. Nice thing about that is that it's kind of like having more pixels on a TV screen. It allows you to see more like higher definition because it's got two wavelengths pulling back from the same thing that it's bouncing off of. So you get a little bit more granular detail. Um, it's to the point where literally just adding this extra beam, you can now tell the difference. That just being like, yes, there is a storm to there is a storm that this part of the storm is very light rain. This part of the storm is very heavy rain. Here's some light hailstones. Here's some heavy hailstones. And if you go far enough up in the atmosphere, there's even some snow up above, like really high up in this storm. So it can also detect things we'll talk about a little bit more here. It can detect things like debris, things that are not precipitation. It can like kind of filter out all the regular precipitation, be like, well, here's an oddity. This is not rain. It's not snow. It's not sleet. It's not precipitation. This is some weird stuff. But that's essentially what dual pole has been able to do for us. So, on average, you've got your little NWS office out there. They've got their dual pole radar. It's shooting its beams into the storms. And it can tell again, the difference. Here's the rain, here's the hail, here's the snow way up here if you're looking at those high elevations. But it's so detailed. It can even like give you kind of a gradient on size of hailstones. It can tell you with pretty good accuracy the difference between like a pea-sized hailstone, like a quarter-size hailstone. It's very impressive. I don't know how it all works. I'm a pretty scientific guy, but it's computer magic basically. So radar modes that we're really going to kind of talk about coming up. Reflectivity is a big one. Kind of already mentioned that. There's velocity, which has to do with really just speed. Precipitation is a really good one, especially during winter. You can really get that granular. This is rain. This is freezing rain. This is grapple. This is like almost hail size sleet. And then we've got snow and heavy snow and things like that. That precipitation depiction is really good. And then there's that dual pole. There's a bunch of weird ones that I don't really frankly understand all of them, but the one I key on is the one that determines where that debris is, which is really good for tornadoes. So we will take this image here. This is just a regular Polygon Warning box. On the right, same box, just with the reflectivity, the composite image overlaid with it. So from this, obviously there's this kind of darker part of the storm. So there's more stuff going on here. And this tornado box tells me that even without the arrow, you've got the narrow part of a polygon box and you've got the wide end of a polygon box. So that should tell you this is the narrow end is where stuff's happening. The wide end is where it's estimated to go over a specified amount of time. So that's usually whatever the duration is that they issue the warning for. It's usually 20 to 30 minute segments. Every warning is a little bit different, but it usually says it's from this time until this time. And from there, again, you can kind of see, even though this is a still image, you get this feeling that, okay, this storm is moving from west to east. This narrow end is where it's at now. The wide end is where it's going to end up here in about 15, 30 minutes or so. So the polygons are really good for kind of denoting that. So this is the same storm, but it's a little bit more detailed. So we went from level 3 to level 2. I think that's, yeah. So with this, there's a lot more pixels instead of just kind of the sort of just kind of the painted on version. Now we've got like real like granular pixelated. Okay, so yeah, in the middle of this storm, there's actually kind of this sort of dead area, but man, there's this little hook action going on here. So it's much more detailed. it can be a little bit messier, and sometimes it's hard to see those polygon boxes. But I just wanted to really illustrate the difference between, you might hear some folks talk about level 2 versus level 3 data. And this is also going to be probably the big difference between some of those weather apps out there and kind of the way they display things. Some might only pull a level 3, which is kind of the more broad strokes. Some might pull a more detailed view, a level 2 that looks like this. I personally would recommend a level 2 just because it gets very detailed. That's what I'm looking for. But this is also not a composite view. It's very hard to tell with all this junk down here. But up in the top left, it says 0.5. So that's the very small, that very low level radar scan. It's only looking at that very bottom layer. So every time it spins, it's only pulling this data. So it's able to do it very rapidly, and you're only getting that thin slice. But that low level is usually kind of where that stuff is that you're really trying to look at on radar for rotation and things like that. So all the different products out there, there's kind of a pro and con depending on what you're looking at and kind of where it pulls that data from. So be aware. So again, this is a little bit zoomed in, but this is the same storm, but this is in velocity mode. So this is showing the wind moving toward and moving away from the radar site. So green is moving toward the radar site, red is moving away from. And that gets really hard to tell, kind of like for direction and things like that, but that's not really what velocity is for. Velocity is really just to kind of see the concentration of those away and toward motions. So if you look at it, you can almost kind of tell, it almost looks swirled kind of in on itself like this, like it's rotating together, because there's the wind that's moving toward the radar in green and the wind that's moving away from in red. And when you get that tight kind of green and red together, that's what's called a radar couplet, which is indicative usually of a tight rotation. So this might be where radar in its algorithm says, there's quite a bit of wind circulating here, like pretty tight together. So that might be what's a radar indicated tornado signature. Doesn't mean somebody's put eyes on it, but there's enough going on. The radar says, it looks like it could be a tornado. I'm going to go ahead and plot that to help get that warning out. Even if it might be a false positive, it feels confident enough to say, I feel like that's probably a not good thing. And so that red, that green together, that couplet can be really telltale. So now here's the difference though between a tornadic event versus a straight line wind event. This is, obviously a very zoomed out view of the area and more of a zoomed in, but notice in the velocity here, we don't have that green and there is a little green and red here, but that's more just like the leading edge of a storm. You don't have the really bright colors right next to each other. All of it's on this green side, which is the wind moving toward the radar station. And it's so powerful that you kind of ramp up from the edge of the storm in the bottom right corner. It's the low level winds. Then as you get further up into here, it gets stronger and stronger and stronger. Some of these darker blues are about 100-mile-an-hour gusts. And so over here on reflectivity mode, it can be really hard to tell necessarily how fast. I mean, unless you're really good at extrapolating, like you really know your geography, you can be like, oh, well, between Topeka and the highway over here, it's about 15 miles. And if it took it 5 minutes, that's a lot of math. Like, unless you're really intimately familiar with that, it's hard to tell what speed is. So velocity can do a lot for you real fast. Just be like, oh man, this storm's booking. It's moving, 85, 95 miles an hour here. And one telltale though in reflectivity for an outflow or kind of a gust front, you can see from where this radar, this kind of reticle is, that runs from the west side of Blue Springs down through Overland Park, Olathe, out near Gardner. There's this little green line that extends out here. That is not actually precipitation. That is enough dust that's been picked up from all these winds coming out from this storm. It's kicked up dust. And so that's that leading edge of that gust front, which is kind of where you start getting from this oh, there's nothing, and then it like ramps up really quickly. So little things like that in reflectivity, as you start looking at it over time, you'll get familiar with these little kind of telltale signs. What you'll often see is you'll see a storm, and you may see this little green line. It just starts moving away from the storm. That's a gust front happening. And that can be pretty damaging winds. There was a tornado on this storm, but it was way out south of Topeka here. But what happened in Kansas City area, that was all just straight line wind here. So going back to tornadoes though, besides that couplet, which again, you can kind of see, this is really zoomed in for a more detailed look, but this is super powerful. It's the reds all the way up into the pinks, and it's the greens all the way into the blue. So this is a very tight, very strong rotation happening. And again, you see that polygon warning indicating, well, here's the tornado warning. And so, yeah, looking at velocity, like I get it. Like we're looking at this very tight, again, you can kind of see it almost kind of swirled in on itself here. And you can see it in this, what's called a hook echo. It's kind of like if you take your hand like this, you got this little part that sticks out here. And you can almost tell, like if you were to overlay your hand with kind of that shape, the major part up here, like where you're, that's almost the direction that this storm is going. I hope that makes sense. So if you're looking at, if you kind of align your hand and you follow like your index finger, that's kind of the trajectory that tornado is going to take. Now, granted, tornadoes can corkscrew and weird stuff like that on a very like small scale, but generally, as far as that whole storm goes, if you were to look at that, as long as you've got a good hook echo like that, you can generally kind of predict where that storm is going to go, at least in the immediate like next like 10, 15 minutes or so. But so this is where you've got the open air curling in, creating that little notch, versus the other part of it that's spinning around here. So you can, again, you can see that swirl right there, I hope. And it lines up. So this is reflectivity. This is precipitation. So it shows us here's light rain, here's heavier rains, here's really heavy rains. Then we get into these pinks. That's a hail core. So, and we've also got all this lightning associated with it. This is the last part I'm going to talk about, couplets. But again, when you've got these greens and reds in a very small scale like this, the brighter colors, again, you can kind of see that rotation happening here. And usually, you know, you might see this even before the warning box gets there, which is kind of an indicator to you as a spotter being situationally aware. If you start seeing that, be like, you know what, maybe I should just go ahead and head home so I can get inside before I have to wait for the warning box, and before the warning sirens go off, and before my phone starts saying, hey, there's a tornado in your area. So the last neat thing here is, like I talked about, there's that one mode in dual pole that can pick out debris. So when you see this, so all the, like the reds and kind of the magentas, that's all different types of like precipitation and stuff, different types of like liquid or frozen water. But then there's this weird yellow and green blob that's in the same spot as this couplet. And what that means is that there is enough debris being picked up and thrown into the atmosphere by this tornado that it's actually picking this up on radar. So that's usually a good indicator that, one, this thing's at least in contact with the ground, and two, more scary, it's probably running through like houses and stuff, picking up insulation and roofing material and throwing this up in the air. So it's a bad thing to see, but it's very indicative of knowing what you're looking at here. So a couple more looks at radar. Again, so if you were to kind of tilt your hand with that hook, you can still kind of get an inference as to what way this thing's going. This is going more in like a southeast or an east-southeast kind of motion here. And again, there's our couplet. And then here are some different types of, some maybe less defined or less impressive hook echoes, because not every echo is going to look the same. Not all of them are going to be really good classic examples. So here's one. It's a little bit smaller, but again, you know, you compare it to, okay, yeah, I see the couplet here. This one, like, there's some heaviness and there's a little bit of a hook, and this one's there's almost no hook on this one at all from the radar perspective. Maybe that's because this is further away from the radar, so it's only seeing it's seeing at a much higher altitude, so it's harder for it to see that hook echo. But again, you start kind of putting these things together, you compare your reflectivity and precipitation and velocity modes, and you can really start to quickly see, okay, no, I see the rotation now. I see what it's talking about. So spotter tip here, both these images on the right are the same storm from the same timestamp at the same zoom level, and you should be able to easily identify one, the tornado warning polygon, which we've talked about, and then the hook echo that you can really see in velocity mode. So again, we got the polygon warnings, pretty straightforward in all the images here. Some of these are a little bit more messy. It's hard to tell. This is without lightning. This is with lightning. Talk about that in a sec. You might also notice the severe thunderstorm warning polygon, which is the yellow one here. And every app's a little different, so you got to learn yours. There's also a mesoscale discussion polygon, which is this blue polygon, which is probably a really big one if you were to zoom way out. And there's also storm reports, which is these little dots with the little, this is wind, this is rain. These are little reports that people can use in their app to report what's going on at their location. So this is good to know. Oh, well, this area, they had some wind damage here. That looks like a roof with some damage, versus up here is just, you know, this is just rain and wind up here. So, but something that you can see, but might not notice, is the way that lightning is clustered. And this is kind of a finding of my own. At least I don't know. Maybe other people have noticed it in the past, but I have noticed very consistently that wherever you have this more severe cells of a storm, that's where the lightning clusters around. And that's, again, talking about all the weather dynamics and things like that we've mentioned so far. Wherever all that energy is happening, that's usually because there's a lot of updraft, downdraft. There's a lot of those dynamics churning and causing, you know, things in the atmosphere to become charged and cause this lightning. So when you see, maybe if you're on a zoomed out scale and you see a whole bunch of like a line of storms, but you see lightning clustering around this one section, that's not to say the rest of the storm might not be severe, but I would be willing to put some money on the fact that that area with more of the lightning is going to be more severe than maybe some of those other areas in that moment along that line of storms. Okay, that was the radar section. I know that's a lot. Is there any questions that came up? Anything that wasn't clear? All right. Cool. Time check here. All right. Looks like we got about an hour left. I think we're on pretty good pace. All right. So now, out of severe thunderstorm mode, back into the doldrums of winter. I know it's boring. I know we're all tired of winter. I know I am anyway, but it's still good information to know. I know we're on the tail end of it, but since now we should all be winter weather experts anyway at this point, I think it's good to maybe just kind of use this as a cap to our winter here. So anytime you're preparing for winter storms, make sure you're checking your emergency kits. Um, your kits throughout the year should change with the season, should be more appropriate to what's going on. So, you know, stay off the roads during and after like a blizzard or a snowstorm. And if you have to be out, don't crowd the plow. Let the plows do what they're out there to do. You know, that's not saying you have to like run yourself off the road or anything, but just try to get over, slow down like you would for any other emergency vehicle. Let them get past you, because honestly, once you get behind the plows anyway, give them a little bit of berth so you're not getting sand all in your car. But you know, now you've got a nice clear road ahead of you because they're clearing all 3 lanes of traffic. You can cruise along. Before you go, clear off your snow and ice. But also clear off snow and ice from fire hydrants. So if you've got one in your yard, if it's to the point where it's piled up and it's almost impossible to see, just, you know, maybe a couple feet just right around it, clear it out. Because, you know, if your house were to catch on fire, you'd probably want that fire truck to be able to find that hydrant sooner rather than later. Using unsafe heating devices indoors can definitely cause carbon monoxide poisoning. It's not a good place to be in. So prepare for winter weather by gathering up your emergency supplies ahead of time. If they're talking, man, like next week, we're going to be like plunging right back into the Arctic cold, that would be a good indicator. Like now's probably the time to go out and get your stuff so you don't have to be out in it later. Same thing for other severe weather. If you've got lead time, use your lead time. So seasons change as well as, your car's disaster kit. Be sure to update your kit for each season. And a quick blackout tip, dim the brightness in your cell phone settings to save battery life. Some phones have like a low power mode. Some have like, you can turn off other notifications besides like priority things, whatever you need to do. But turning down that brightness can really extend your battery life, especially when it comes to power outages and things. Something I find kind of neat is the different types of winter precipitation, just because of how the warm air aloft impacts it. So we've got everything here from rain to freezing rain to sleet and snow. And it really just has to depend on, if they're, and by warm, we're not talking like balmy here. We're talking like maybe just a little above freezing versus the rest of the air being just a little below freezing. A little bit of a variation, even a couple degrees or a fraction of a degree, can make a big difference in how precipitation hits the ground. So, if there's enough of a deep pocket, what would be expected as snow might be falling as rain. But then, you get a little bit lesser pocket. Now you're talking freezing rain as it hits the ground. Again, as you reel back the amount of warm air aloft, then you start converting over into, like sleet, grapple, maybe some mixed precipitation in there. You might have a couple flakes with some pellets. But then if there's no warm air aloft and it's just, a straight fall, then that's why we get snow versus some of these other things. Winter weather kits. So in your house, they suggest per person having at least 3 days of water at all times. You've got your medications, you've got batteries for whether that's for emergency devices, flashlights, radios, things like that. But then you also have the device, so your flashlight, your actual radio, a crescent wrench, which you can use if you've taken a CERT class. You should know we use the crescent wrench to shut off gas supplies. If you smell gas, you might be your first line of defense to securing your house from blowing up. So know one, where that is, and two, how to use the crescent wrench to turn that bad boy off. Having some extra clothes and boots around. So if you need to bundle up, God forbid we end up in a situation like Texas has been lately with all these people in the cold without power. That is a terrible situation. So, have these extras just a little bit on hand. And don't forget your pets. I've got a dog and I've got 3 cats. So, every bit, there's more of them than there are of my family. So, we got to make sure they've got their food and they've got water too. Or if, they've got medications, you got to do that too. Any important documents, say, maybe keep things in a fire safe that you can kind of take with you in case your house becomes unlivable. Maybe it's going to be too cold for too long and you need to get out. You need to go to a shelter. It's good to have your IDs and stuff like that kind of bundled together so you can just take it with you and you don't forget it. Rock salt for outside, shovel. You might have to dig yourself out of a house if it was a really bad winter. First aid kit, cell phone chargers, those types of things. Then you've got your car kits, which is basically the same thing you'd have for your home. It's just a lot more scaled down, a little more oriented for your car. So in this case, you've got your ice scraper, maybe just a little bit of water and non-perishable food. I also recommend the pop tops versus the tops that you have to have an opener for. Save you a lot of time and frustration in an emergency. Pro tip. Kitty litter is good to have for, kind of one, using the shovel to kind of dig out around your tires if you get stuck. But then if you can get a little bit in there, you might be able to get a little bit of a traction to kind of get yourself out of a stuck scenario. Your flashlight, again, another phone charge cable, and then again, some extra clothes just to have in your vehicle.
Hey, Justin, a quick note for you. When you're referring to your images, if you want to be a bit more specific about which one you're talking about, a couple of people have noticed that they're using smaller screens, so they can't quite see what you're referring to specifically. So
Okay.
just a quick note.
Sure. Yeah, sorry about that, guys. We will also be, like I said, we'll be posting this video. So later today or early tomorrow, if you want to go back and kind of check some of this out, maybe on a bigger screen when you get a chance, you'll definitely be able to see some of this stuff a bit better. And I'm also going to try to find a way to share the slides. It's kind of big, so I'll have to figure out a way to share it like from Dropbox or something. But I'll put a public link out there for like a view only. So if you guys want to go back and refer to this, by all means. I think I was talking about pets. If you're gonna have to like evacuate your house, or even just like taking them out in severe weather down here in the bottom left, maybe try to cover up their feet, maybe give them like a blanket or something like that. If you've got to like walk to a neighbor's house like down the street or something like that, if it's super cold out, sure, they're stout as animals and pets and things like that, but their feet can get frostbitten just as well as yours. So make sure you're taking proper consideration of your pets. Then in the lower right here, using an unsafe heating device indoors can cause carbon monoxide poisoning, such as like portable gasoline heaters, propane heaters, natural gas heaters, and charcoal heaters. Hopefully none of you guys are using any of that stuff indoors. Um, try to keep that stuff just for outdoor spaces only. And then there are still some ways to, enjoy the winter outside stuff, if that's your jam. But limit or abstain from things like caffeine and mood altering substances. Those can make you feel like you're warmer than you are, and so you're less inclined to be as bundled up. Also, notify others of your plans. If you're going to be outside for a while, doing whatever. I always tell my kids, like, if they're going to play outside, like, either you come back in like every 15 minutes to be like, hey, I'm still alive. Or, if they've got their phones with them, just kind of a what I call a life check. I'll message them. If they don't respond back right away, I'm going to go out and find wherever they're at. But just so people know, if you're out and about, that, to check in with you, it's a good kind of safety line to set up. Dress appropriately, don't expose your skin to extreme cold. Frostbite is not fun. Beware of overexertion. Just existing in a cold environment for the human body takes so much more effort for your body to deal with that. Just being out in the cold is tough. Then the more you're doing on top of that, you're like doubling, tripling, quadrupling the amount of effort that your body systems are exerting. So just be very careful. Be mindful of how your body feels. Maybe keep an extra set of dry clothes, especially if you're going to be like camping or something like that. Know the nearest place to take shelter. Watch for signs of health problems. Keep your devices charged for communication, whether that's a radio or a phone or something. And then waterproof matches and paraffin fire starters are a good way to go. I'm a scout. We used to go cold weather camping all the time, so I wanted to make sure to throw that in there for any outdoor folks. So have fun.
Yeah, a couple of questions in the chat,
Sure.
Justin. One in regards to a FEMA website that has some of this information. She asking if it's ready.gov. I think it is.
Yeah, ready.gov has like anything and everything. Their website, you can really drill down to like very specific topics, and they've got all kinds of things there. Let's see. Friends from Iowa mentioned using kerosene catalytic heaters. I think kerosene indoors is probably a bad way to go. I don't know anything about kerosene, but I feel like using kerosene inside, the amount of carbon monoxide that can put out seems, or even just the fumes themselves, I would not recommend that at all. Again, I'm not a pro there. I'd look it up to verify that, but just off the cuff, that sounds like a really bad idea.
Yeah.
So I hope they're staying safe. Anything else that I missed? No, looks like that's it so far.
No, we're good.
Okay. So on this slide here, depending on how cold it is outside really determines how you should be dressing. So in this example, there's chilly on the left, there's cold in the middle, and there's the extreme cold on the right. We have fortunately gone from extreme cold in the last few days over to cold, maybe even chilly a little bit. So we're warming up, but it's still cold outside. So at the At the warmer of the cold areas, 1 to 2 layers, some long layer pants, maybe a sub layer, some warm shoes, hopefully waterproof, an outer layer to keep out rain and wind. As it gets colder, increase the amount of layers that you have, maybe a more sturdy coat. Make sure it's waterproof, again, to keep out wind and wet snow. You probably want to use gloves at that point if you're not already. Probably a couple layers of pants, maybe some taller boots, again, waterproof, and a warm hat. And then for that extreme cold, whatever you can do to keep yourself insulated, lots of layers, maybe even double hats. Besides your COVID face mask, also like some sort of like winter rated, mask to keep that cold. Is the least amount of skin exposed to the extreme cold, the better. Maybe even like ski goggles or something like that, just to cover that little bit of an area that your masks don't, and your hat. Maybe even like a long outer layer. You can get those bigger coats that kind of go down like below your butt, and they've got collars that sort of like fold up around, kind of, and any little bit of extra that you can do there. Even going with like a thin glove layer and like a thick outer layer. Long socks on top of long underwear underneath some thick boots. More layers, the better. The colder it gets, basically just keep layering it up. All right. This is very important. Warning signs of hypothermia. And not any one of these is necessarily an alarm sign, but knowing these things, especially when looking at somebody or even like just being aware of it yourself when you're out in the cold, can be very, very important. So you've got confusion, lots of shivering, like uncontrollable shivering, difficulty speaking or slurring of speech, drowsiness, sleepiness, and then stiff muscles, especially if they're experiencing more than one of these and it's cold out. That is a problem, or at least should be treated as a problem. Those people need to get inside, need to start warming up. Probably should seek medical attention, but be very aware of these things. The cold can sneak up on you in not great ways. This is kind of a cute graphic, but also kind of helpful about walking around in the snow. So in the lower left here, it talks about like when you're walking regularly, you shift your weight from foot to foot. That's normal, not icy situation. But in ice, kind of leaning forward a little bit, keeping your feet always on the ground, and just sort of shuffling while keeping more of a straight up and down center of gravity on whatever foot is towards the middle. It's kind of that, waddling like a penguin, sort of keeping your feet on the ground as you sort of just slowly shuffle. Keeping that, again, your weight very centered up and down like that is very helpful. Sometimes that's about the only way you can move around if it's super icy outside. But during wintry weather events, the ground we walk on can be basically every bit as dangerous as the cold air itself. If you fall down and you shatter your hip or something like that, you might not be able to get back inside. And so now you're outside and now you're in the snow and you're on the ice. That's not a good place to be in. So it's always best to shovel off what snow you can before putting out sand or ice melt, just to let the ice melt really just work on the ice itself. Snow and ice that melts during the day can quickly turn back into the ice or back into ice as the sun goes down and the temperature drops. It may even be black ice to where it's like, oh, it looks like the driveway is just wet. But if it's cold out, it very well may have frozen into a very fine layer of almost imperceivable ice that is exceedingly slick. So be very cautious. Keep those feet shuffling. I really like this graphic. I found it a couple of years back, but this guy on TV was telling people, I think this is a little bit more southern location, who's talking about here's how to drive in snowy weather. So imagine if you are you rarely drive in the snow, so just pretend you're taking your grandma to church. There's a platter of biscuits, there's 2 gallons of sweet tea and glass jars in the back seat. She's wearing a new dress and holding a crock pot full of gravy. So if you drive with all of these things in mind, I know it's kind of a funny way to think about it, but the long way of explaining this is leave early, take it easy. Like, don't overcorrect. You don't want to do like jerking motions with your steering wheel. Go slow, keep your headlights on, buckle up, have your winter emergency kits obviously in your vehicle. We've talked about that a lot. Leave lots of extra space between you and cars in front of you, and move over for emergency vehicles. Again, don't put your car in a precarious position, but just slow down, move over to the right as best you can without getting stuck. Let the emergency vehicles, the plows past you, and then ease back on the gas and get behind them. So, any questions about winter weather? Probably not, because we're all pros. Yeah, really extreme cold, just stay inside. If you can just stay inside during extreme cold, that's the best way to go. But
There's a question about ventless natural gas heaters. I've never heard of those, but I don't know.
I don't know anything about those. That's a good question.
Yeah. And then another person mentioned, just remember that your clothes don't make you warm, they keep you warm. So
Yes. Your own warmth comes from your body. So all those layers is what keeps your warm in. Once your warm gets out, you're kind of out of luck at that point. So you've really got to kind of get back inside to start regaining that inner warmth again.
yeah. Also, four-wheel drive doesn't do you much good.
Not on ice.
Yeah, not on ice, and
Car
at
emergency
fast speeds either.
There are some places that sell little emergency kits. I want to say I've seen it maybe like Hy-Vee or Walmart. Some varying size ones you can buy. It's like they're little, just like kind of winter starter kits. There's also, I know I mentioned this later, but for any type of emergency kit and thing like that, going back to what Kathy said with ready.gov, there's lots of great resources out there. There's also a ton of videos on YouTube. You could literally just type in how to make a winter car kit and there'll be a million videos. So some of them go like super extreme into like, hundreds of dollars of stuff. Don't let yourself get overwhelmed with that. Basically look for like the gist of what they're getting at. Make it applicable to you and your situation, where you're at, and kind of the weather that you can expect. And then, go from there. Start small. But start early. Like, even if it's in the summertime, if you see like, oh, ice scrapers, but it's in the middle of summer for like $1 a piece, shoot, buy a couple of those up. Put them in your winter kit for when you eventually get to your winter kit. Right now is when I start looking for some of my summer stuff. If I can find like batteries on sale or whatever, because we're kind of like post Christmas now. We're not, it's like super high demand, but we're also not quite to storm season yet. So sometimes you can find good deals and things like that. But yeah, keep an eye on that stuff. Even if you find something that's out of season, buy it when it's on sale. Put it in your kit for later. It's a great way to start like slowly buying stuff up over time. All right. So getting kind of back out of the winter mindset and just more into like spotter mindset here. What weather should spotters pay attention to? And really at the end of the day, it's everything. Just because it's nice when you leave the house does not mean it's going to stay that way. Weather is dynamic. I feel like we've covered that ad nauseum at this point. It's ever changing. During warm months, a cloud can turn into a storm, can become severe, and then produce a tornado in less than an hour. I've seen it happen. It doesn't take a lot. So if you remember anything about like July of 2015 in this area, we had several rounds where things got pretty nasty pretty quick. Be sure to check for updates more often on those higher risk days. So if you get up and you see the outlook says, oh, probably like an enhanced risk, that should be your first step or first reminder to, check your radar from time to time. If it says, hey, after 2:00 in the afternoon is really kind of when we expect things to start kicking off. So, okay, maybe around 2:00, then I should, or maybe even a little bit before 2:00, I should check the radar. I should check and see if there's an update from NWS Kansas City or from my favorite Chase team or something like that. See if they've said anything about what's changed since I got to work today. If the skies are starting to darken when they shouldn't be, try to get a weather update. If things look weird, get yourself updated. You should have lots of ways to get notified. And when the sun goes down, that does not mean that storms will necessarily weaken. Storms can be every bit as powerful at nighttime as they are during the daytime.
Mm-hmm.
These are just some general storm stats from 2017. Really, for us, we'd be like looking at flood, lightning, tornado, not hurricanes up here in Kansas City. Heat deaths is a big thing. That's even more than flood. That was a little shocking to me. The 30-year average for heat deaths. Now, granted, it's the 30-year average is real high with that, but it's starting to come down a little bit. And then we've got wind, cold. That stat's probably going to go up a bit. It's been extremely cold this year, and winter weather. This is really going to be hard to see on a small screen, but essentially, if you can even just make out the general colors here, all the blue, that's severe wind and wind damage reports across the US. The little red dots sparsed in there, that's confirmed tornadoes. And then the green is severe hail. Now, a lot of these are so tight, they're just sort of all overlapped. But I feel like this does a good job of showing you that really just about anywhere in the country, you can get these types of severe weather. Now, granted, there is definitely a bias east of the mountains, but that makes sense geographically. It's harder for that kind of weather to happen in the mountains, but man, once you get east of the once you get really east of the Rockies there, it's a free-for-all. So as you can see from the bar graph down below, everything between March and August are the more active severe weather months, with May being the typical danger zone for most of it. May's got a lot of high graphs here. Though, don't be shocked where you see the late part of February and the early part of March, which is where we're at right now. Once we start seeing these big cold air masses and these big warm air masses start battling it out for the beginning of spring, you can get really nasty weather. So keep an eye on that. Keep that in mind for the next, week or two. Severe weather, I'm going to say it again, can happen any time of year, any time of day, any time of night. Missouri alone had 2,242 severe weather reports in 2017. So again, that's severe wind or wind damage, confirmed tornado, and severe hail. That's just those three stats. That's a lot. So how would we recommend that you get weather information? So first and foremost, as like your backbone, kind of your last resort, not necessarily last resort, it should be a pretty stable way of getting notified. The old school NWS weather radios. They make them really easy to program these days. Granted, they use, county warnings, and they're not necessarily using Polygon warnings, but they're reliable, they're loud, they'll wake you up. So make sure it's got batteries, make sure it stays plugged in, make sure it's set to on, and that it's set to the right county or the right zip code, and you should be pretty set. NWS Kansas City or the Storm Prediction Center, they've got their websites, Facebooks, and Twitter. You can get a lot of great information just from those two alone. Local TV news stations. Yeah, it's old school, but they've got TV, websites, Facebooks, Twitters. They've got their own phone apps. They have a lot of stuff that you can use to get that information. There's also, other trusted people or groups on social media, which includes, people like us, chase teams, private meteorologists, forecasters, weather enthusiasts. Caveat to that, just make sure that their information checks out. I would hope that before you started following us, you vetted what we're saying against like National Weather Service or the broadcast guys. 99% of the time, we're probably just going to be rehashing what they say. Sometimes we'll throw on our own thoughts along with that, but absolutely, if you're looking at other people's information, like I'm not a meteorologist, I never went to school for it. I'm self-taught, but I've been in the game long enough and I take the stuff seriously enough from a spotter perspective, an emergency management perspective. I want my information to be accurate, so that's what we strive for, but that's not the case with all teams. Some teams are out there just to take pictures. That's fine. That's what they do. I would probably look at them for pictures, but not maybe necessarily listen to them for, an update or alert or something like that. But phone weather apps, I know we've talked about that a lot already. There's the Red Cross apps. They've got specific ones for like storms and earthquakes and hurricanes. There's Radar Scope. One Weather, WeatherBug, Weather Underground, AccuWeather, MyRadar, StormTrack, Arcus. There's a million apps out there. Download a few of them, download a handful, check them out. Whatever you don't use, get rid of. But there's a lot of great apps. It really just depends on what works for you, what looks good to you, what is understandable to you. Make sure that you can set up geolocations so that you get notices that are specific to you, so that they're actually good information based on where you're at. There's also good computer apps out there, paid and free. Now there's websites like Pivotal Weather, there's the GOES website, GR Earth or GR Analyst, WeatherBug, F5 Data. Again, tons of apps out there. Feel free to try them out. Last and probably least would be the local radio stations. They're there to play music. They're there to have their talk shows. But at least if there's a tornado warning, they will break into broadcast to at least play that alert tone with the automated message saying, this is what's going on. Here's where it's at, that kind of thing. I would not rely on it, but if it's all you got, at least, keeping a radio on in the background so you can listen for that sound, that'll still be helpful to some degree. Who can you trust for weather updates? Well, we kind of covered that a little bit, but regardless of where you get information, these people, I would say, kind of in order of priority here would be our personal recommendation. So there's NWS Kansas City. That's our local NWS office. Absolutely. That's what they do. 24 hours a day, 365 days a year. Good information. There's also the National Weather Service Storm Prediction Center, or SPC. That's kind of the national level, but they work very closely with all of the local offices, and they also put out very good information that's often shared between both entities. Then there's the news guys and girls, Fox 4, KCTV 5, KNBC 9, and 41 Action News. Pick your favorite. I have my favorites. It's a personal preference thing. Whatever works for you, kind of like weather apps. Local emergency agencies. We try to publish those watches and warnings. When I say we, I am talking from my emergency management side, not my Twisted Skies side. We do try to publish that stuff, but you might also watch other nearby emergency agencies too, just as information. When things really hit the fan, emergency management agencies will really switch from being like weather specific and on top of it to, okay, well, now we're on the dealing with it side, and we're working to put out information on, here's a shelter, here's where you get your vaccines, here's what the current boil order information is, like that kind of stuff. So we kind of move away from the really up to date on the weather and more of the, hey, yeah, that stuff's still going on, but here's other information that's really our primary focus kind of thing. So again, if you know of any local enthusiasts, private meteorologists, forecasters, or chase teams, just be sure to vet their information against other sources, please. Vet me against it, vet Pete against it. That's fine. I would rather you make sure that we're legit than just listening to us because we said you should. Something that still kind of grinds my gears is when people talk about, forecasters can get it wrong half the time and still keep their jobs. It's a lot better than half the time. Yeah, sure. Very, very hyper local. They might be off a bit, but really geographically, if it's within 50 miles, I feel like they pretty much nailed it. There's a lot of dynamics and a lot of hardship that goes into that. So that being said, this is an outlook, these colors from December of 2015. So that's 5-6 years ago. This is the outlook that came out in the morning. And as the system rolled through, all these little black boxes on here are tornado and severe thunderstorm warnings. And you can very clearly see those densities line up pretty well with those warmer colors. Now, you can also tell, excuse me, these long boxes, those are the tornado warnings, and some of these weird box shapes, those are more of the severe thunderstorms. So all of these concentrated long boxes, those are the tornadoes, and those are right there on that orange and red. That's a very accurate forecast. It's a very accurate outlook. Generally speaking, I feel like there's a few outliers way out here on the south, but for the most part, this forecast was spot on. So don't be one of those people that says, forecasters don't get it right half the time. I will fight you. Okay, so everything we've talked about, if you don't know where you're at and you don't know your local landmarks and things like that, none of this makes any difference. whatsoever. Knowing where you're at is so important. And I cannot stress that enough. So just following along here, I'm in Independence, which is not on the map, but I know it's in north central Jackson County. So right there on the map. I know that Jackson County is a county in west central Missouri. And I also know that, okay, well, these are the counties around me, and I should probably know at least maybe one county, or at least with one county deep from me, kind of what those counties are around me, so that as weather's happening and say, hey, in Cass County or hey, in Platte County, I have at least a general idea as to where that is. So that if they say, hey, in Platte County, blah, 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 and it's heading southeast at 60 miles an hour, I know, okay, well, Platte County, that's to my northwest. It's generally heading my direction. I should probably take that as a cue to pull up my radar app or something and look at what's going on. Maybe it's going to skirt by me. Maybe it's going to go, through Lexington, Missouri, or maybe it's going to go way down south towards Cass. But I need to take a look. I need to use that heads up time and start taking a look at this stuff. So also with this map, you can see like all this green area, that's all National Weather Service Kansas City area. All this purple is Springfield, NWS. Then you've got a little bit from Davenport in the red. The yellow is St. Louis, NWS. The gray is Paducah. And then way down here, these couple of counties, that's the Memphis, Memphis NWS. So even within one state, there's still several offices that may overlay, but all these offices can help each other out too. So going back to a national level, here's just kind of a look at all the different NWS county coverage areas. You can see total area wise, maybe not as big as some of the others like Salt Lake City. They cover a ton of counties. Look how big these counties are out here. There's nothing out here. Our office in particular covers 42 counties. I think 42, somewhere between 42 and 46. I'd have to recount, but that's a lot of counties and that's a lot of geography. We're talking, the corner of Missouri up here between Nebraska and Iowa, all the way down to, what is that like? I can't think of what it is. It's like a dare.
Nevada,
Missouri, basically. Yeah. And then as far east as almost the Mississippi River over there in that northeast corner of Missouri. So geographically, they cover a big area. And people were like, hopping in NWS chat and they're like, well, when's the ring going to start at my house? And it's like, come on, man, like take a little bit of responsibility for yourself, know where you're at. They're trying to cover this forecast for this huge area and you're lighting them up on socials saying, well, I want to know when it's going to start raining at my particular ad. Like, that's not cool. Don't be like that. This is the part where, these other agencies like NWS and the broadcast meteorologists and emergency management, they're doing like 95% of the work to get the general information out there. And we as people have to be responsible for taking that 5% of effort on our side to know where we're at and like what's going on in our general vicinity, to know enough to take what that general broad strokes is and apply it to us. The same as it's up to us to have 3 or more ways of getting notified, not just relying on it to happen. Does Pleasant Hill cover any of Kansas? Yes, it does actually. So it's a little hard to see right here, but on this map, there are about 1, 2, 3, 4, 5, 6, 7 counties in Kansas that NWS Kansas City covers. It's basically from Atchison, I think, because that's the county that's just on the other side of the river from like St. Joe, all the way down to it's probably not quite Pittsburgh, Kansas. I don't think it goes that far down.
Yeah, I think, what is that tiny town there? Iola?
Yeah, it might be a little bit further than that, but it's basically all there's 7 or so counties right along the state line area that NWS Kansas City does cover. All the rest of that, a little bit west of that's going to be the NWS Topeka, or as you go further on down south, it's going to be NWS Wichita. Spotters provide situational awareness. We do, but it's still on us, like I was saying, to take at least some personal responsibility. So, you know, a quote here from this particular county sheriff during a news conference said, you know, if you decide to stay in your home and a tree falls on your house or the storm surge catches you and you're now calling for help, there's no one that can respond to help you. This was before Hurricane Michael. They had told people, hey, you need to evacuate. We're the people that are providing the message, but you've got to take that personal responsibility and actually do what we're saying. Otherwise, I mean, you can stay in your home. You have that right, but don't get mad when you do that, when we've told you to leave, and then expect someone to just be right there for you to be able to save your butt. There's a small level of personal responsibility that people have to put on themselves. And that's just facts. This is why it's imperative to follow the directions given by emergency management, National Weather Service, and broadcast meteorologists. They don't just do it to hear themselves talk. It's to save lives and property and to give people the best chance of mitigating a disaster. Granted, there are always situations where people are not going to be able to do that. And that's understandable. But I'm talking about the people that blatantly say, oh, I'm not going to do that. Nah, that's not for me. That didn't apply to me. But then they get mad when, you know, they kind of poo-pooed on what everybody else has said, but then they expect emergency services to be at their every beck and call when they're in the middle of a disaster zone and thousands of other people are also in a bad situation. So if you fail to heed the proper preparedness actions, you could absolutely become a victim, waiting days or longer before you're helped. Roads, power lines, internet, phone service, gas lines, roads, all these could very well be disrupted and have to be fixed at least to some degree before the rescuers can even get to you. Infrastructure, I'm going to tell you from an emergency management standpoint, yes, people's lives are important. And yes, that's always the top priority. But sometimes you have to fix the infrastructure before you even have a prayer of a chance at getting to people. There are some things that have to get fixed before they can even risk other people's lives to go help those people. That's just how it is. That's real world. And that's not that they don't want to come and help those people, but that's how it works. It's not a good situation to be in, but this is why we talk about preparedness and mitigating and taking some responsibility to try at least to do what you can to be ready for this stuff. Preparing for severe weather and other disasters ahead of time is every bit as important as knowing what to do after a disaster strikes. Some spotter terms that you should know. As with a lot of other things, you know, there can be some misunderstanding between certain words and vernacular and things like that. But the big five are emergency, warning, advisory, watch, and outlook. And that's, I think, there is one exception to that, and we'll cover that next. But an emergency is the absolute worst case scenario, typically involving the potential for massive loss of life and total devastation, where a failure to act will likely lead to death. Then you've got warnings, which are the kind of bread and butter, the real common, like, you know, you hear warning, you hear watch, like those are terms you hear a lot. Warning is often associated with things like floods, ice, blizzards, thunderstorms, tornadoes. When you receive the warning, it is imperative to take action immediately. An advisory, you know, oftentimes those are like additive information. They might go along with or be supplemental to things like watches and warnings or emergencies. Advisories are usually like, hey, like this is going to be kind of a long-term thing. So like this advisory now is either like we've got a little bit of time beforehand to kind of expand on this, or this is still going to be going on for a while. This advisory is like additional information about this watch or additional information about this warning or this emergency. It's always good to look at advisories. Watches, again, that's the type of notification that indicates that weather has a good likelihood of happening. And excuse me, anytime within like the next few like minutes to hours, sometimes earlier, sometimes later, but the watch time, like that's the time to get ready. Taking the times to have things prepared in case of an advisory, warning, or emergency later on. Outlooks, again, those are probably the most mundane. but those are the like broad strokes, like, hey, here's our thinking, here's our general like timeline. It's the big picture. Outlook is the like, here's the general framework for what we think today or tomorrow or the next couple days. And then that one caveat that I said, there is another term, PDS, which is a particularly dangerous situation, which might be applied to any number of things: a watch, a warning, an advisory, an emergency. It's kind of a wild card that gets added on these things. So it is a type of enhanced wording for all manner of severe weather watches, warnings, advisories, and it is issued at the discretion of the forecaster composing that watch or warning or advisory to convey the risk of very severe and life-threatening weather, usually like a tornado outbreak, an extensive flooding event, a long-term duration where it's just like storm after storm after storm in rapid succession, intense severe thunderstorms. Fortunately, PDS statements are very rare and only for extreme cases. Less than 3% of all SPC issued watches are qualified under like the PDS watch category. For more information about that, you can either ask your local office or just Google or look up on Wikipedia, particularly dangerous situation. It's kind of interesting about kind of how it came to be and like why the term is used, but this is at least the nuts and bolts of it. So in a nutshell, I would hope that at this point you should know absolutely the difference between a watch and a warning. The watch is the be prepared, kind of run through your checklist, make sure you're ready to go. The warning is you act now. Warning is the take in action. Then there's tornado sirens, the song of our people. Tornado sirens are just the outdoor warning sirens. They're for warning purposes, but they're not meant to be heard indoors. Yes, you may hear them indoors, but they're not meant for it. Hearing a siren is a signal to move indoors and seek additional information. It does not mean that the threat has ended when the siren stops sounding. And sirens are activated by city or county officials, not NWS. So if you're mad about it, if you don't like when it was set off or where it's placed, don't take it up with NWS Kansas City. That's going to be like local emergency management, sheriff's office, police department, something like that. It's not NWS. They put out the warning, and it's up to jurisdictions to have a siren policy to determine how and when those sirens go off.
A little bit more on that. Sometimes they can set off those sirens without the direction of the National Weather Service. Occasionally, you might hear them go off for extreme wind events, depending on situations. It's categorically up to the particular location.
Yep, I can say that. Yep. I can say that as the storm spotter team lead here in Independence, I have had these conversations with some of our like policymakers and the actual like paid staff and stuff, and we have submitted. I think it is our current policy that if we have a sustained wind, it's either 70 or 75 miles an hour, we kind of ratcheted it up a little bit. But if we have a sustained wind gust of, again, like 70 or 75 miles an hour for over 1 minute, we will sound the sirens due to a wind event. Even if it has nothing to do with the tornado, it is a long enough duration of extreme wind that can cause enough damage to be what we would consider a threat to life and property. There's a lot of old trees. There's a lot of older homes. It's something that has caused a lot of damage in the past for us. And basically after that 2015 windstorm that I talked about much earlier, that was when we started kind of thinking, maybe we should have a policy for that in place. I don't think we've had to issue it yet, but we have come close a couple of times. So again, yes, what Pete said, it is very much up to each jurisdiction as to what their sirens are used for.
Yeah. Part of the issue is there's no federal guidance or regulations on sirens. It's all local. There's best practices, but there's no directive.
Correct. So one of the things that I would like, if I could give you a homework assignment, is for us to help educate others that aren't as weather savvy or weather, I guess, educated about sirens and siren dependency. And again, I'm going to refer to James Spann on this because it's something that he is very passionate about. So I'm just going to read these next couple slides to you. Siren dependency Let me make this perfectly clear. Sirens do serve a purpose in the warning process, but please understand they are a last resort. They reach a limited number of people outside. They have never, ever been effective in reaching anyone inside a home, business, or church. You might hear a siren on a bright sunny day, but hearing one in the middle of the night during a raging storm when you're asleep will never happen. Way too many Alabamians use siren systems as their primary way of getting severe weather warnings. This siren mentality has killed countless people in our state over the years. What's up here? Oh, yeah. Catherine works with me, so nice to see you, Catherine. Yeah, this is stuff that I talk about a lot with people, like as I'm talking about weather and things like that. Is like, one, sirens do serve a purpose, but they should never be anybody's first line of defense. They should be like an extreme worst case last scenario kind of thing. And then the second part of this is, here's the what I would say is like the homework assignment part of this is, we must do a better job of letting people know that warnings do not cover entire counties. They may be issued for them, but they don't ever cover an entire county, only small parts. So the bottom line is that people should have multiple ways of getting severe weather warnings, and they should pay attention to severe thunderstorm warnings. The baseline for every home and business is an NOAA weather radio. Again, are they perfect? No. The fact is, weather radios are still based on the old county warning system from years gone by, but they are very loud and they will wake you up in the middle of the night if there's a warning. Second tier is a good smartphone app, which is something we've talked about a lot today, designed for warning dissemination. Again, there's literally thousands of weather apps in the store on your phone, but make note that most of those will not warn you in a timely fashion during severe weather. That being said, there are some good weather apps out there that will notify you, but you've got to make sure you find one that's designated as like an alerting type app. And that's only going to be really something you find out through trial and error with these things. So the key here is, again, having these multiple ways, these multiple layers of getting these notifications and being educated to understand what's going on. So part of those other ways, we've talked about local TV and radio, outdoor sirens. They are one of the layers, but should not be your first. Friends and family, maybe set up like a phone tree between like you or your church, like a group or something like that. It's a great way to do things. Like somebody's like the first person, like the primary, and they kind of like call the next person. They call the next person. It can be a little slow, but it might be better than nothing, for other people that don't have a lot of tech or are comfortable with tech. Maybe they need that personal level of phone call. That's understandable. There's also the internet. There's wireless emergency alerts and weather applications. There's weather radios. This is a tweet that I posted not too long ago, that national and local media and the general public need to understand that warnings only work if people have the ways to receive them. And that's what I said. It's that 5% on us as individuals to take our own responsibility to say, okay, there's all these ways of getting these notifications, but I've got to do something to make sure I get that notification. And then, getting a warning could save your life. Here's all these other different ways here. This is a tweet I saw just in late January here, about a month ago. This guy says, got my wife and baby out of bedroom about 10 minutes before this happened. We are in Darlene Estates in Fultondale. Thank you, weather radio. So this guy had a weather radio on his nightstand, and he got the weather warning and got his wife up and got his baby out of the crib. It might be hard to see. This is a picture of a bedroom. There's like this big 2x4 busted through the wall and impaling one side of the bed here. If this had been 2.5 feet one way, that would have been through the baby. It would have been 2.5 feet the other way. It would have been through him or his wife. But they got the warning. They took the responsibility to have a way of being notified. Said, okay, we've got the warning. I need to go to my safe place. And in 10 minutes time, this came through and could have very well killed him, his wife, or his baby. I know this is an extreme example, but this type of stuff happens every single day. You've got to take the responsibility to go that little 5% to just do what you need to get those warnings. that little super annoying warning in the middle of the night. This guy posted this at 1:15 in the morning. You've got to have a way to be notified and to wake you up in the middle of the night for this type of stuff. I would rather do it 10 times and nothing ever happened to my house than not do anything. And the one time I don't, something happens to me or my family. So here's a weather radio. Here's a ham radio, which, you know, usually you can tune that over to listen to those weather channels. There's also the FRS radios, which those are the little handheld ones that you can get from just about anywhere, walkie-talkies, things like that. There's a weather band on those. You can just pop over to that weather band and be listening to weather radio. So there's definitely, even just in the radio scheme, there's multiple ways to be aware. One thing that's really kind of come up recently, especially with Texas and things like that, is power outages. You know, stay vigilant as spotters, especially during power outages. If you're out and about, if you're traveling around, I know this is from the state of Georgia, but this I feel like is pretty universal in that, you know, if there's no signal light at all, treat it as a four-way stop. If it's flashing red, again, the same thing, treat it as a four-way stop. If it's flashing yellow, I mean, you should probably at least come to a stop and take a look before continuing. Essentially, unless the light's working, treat it as a stop. Always stop. Look, even if the signal light is the only thing that's even partially working, but there's no other lights on, then, you know, that could be really bad if you just happen to plow through an intersection and then somebody who's, you know, freaking out cuts you off or plows into you through this intersection. Blackouts can be really scary. People freak out during blackouts. Some other things, you know, power outages, especially long-term, may disrupt communications, water transportation. They might close retail businesses, grocery stores, gas stations, ATMs, banks, other services. They can cause spoilage like water and contamination. They can prevent the use of medical devices. So some safety precautions during at least long-term outages would be to like keep freezers and refrigerators closed, disconnect appliances and electronics to avoid damage from electrical. Though I will say, make sure to keep like just a lamp or something plugged in so that if power comes back on and your light is at least switched to the on position, when power comes back on, that light will be like, oh, hey, power's back on. But other than that, really disconnect everything else, especially sensitive things. Use generators outdoors and away from windows. Use alternate plans for refrigerating medicines or power-dependent medical devices. Do not use gas stoves to heat your home. If safe, go to an alternate location, maybe a friend's house or something like that, for heating or cooling. And then also, if you can, check on neighbors. For people that are otherwise abled, for elderly, frail, people that have been sick, things like that, you know, it's good just to check on them. They're a little bit more vulnerable than, you know, other folks that are able to, you know, still get out and be mobile and things like that. And also a key point down here in the bottom is that solar chargers and battery banks can help dramatically extend the life of smartphones. So you can buy those they're like little kind of brick shape, but they're flat, usually with like little USBs on them. You can charge them ahead of time. They just keep a charge. So if your phone runs out, you can plug into that, even if you don't have like an actual outlet, and you can charge that way. We are almost done, folks. Again, don't forget about pets. Make sure that, you know, get your pets ready at the first sign of an approaching storm. You don't want to have to be fighting them. You don't have to be worried about rounding up all their toys and things to keep them calm on top of your kids and on top of everybody else freaking out in your household. So keep them ready to go. You know, have your leash kind of ready to rock. Maybe keep some stuff in their pet carrier. You know, have their food, have their meds, have some water. Maybe even just designate a small little area down in your basement or something like that that just has kind of a little backup supply that you refresh every once in a bit, and make sure to include their food and their medicines along with things for you. They're members of the family, so make sure they're taken care of. Some general broad stroke safety and prep stuff for all hazards. Make a communication plan. There's great resources, again, ready.gov and things like that. That can be a whole topic. That go bags can be a whole topic, but try to think in the terms of, what if you can't use your cell phone or the internet? Keep at least one, preferably more, out of town contacts. For me, that's my dad. He lives in Indiana. So if something terrible were to happen in this region, I can text him. I have a way higher chance of that text reaching him outside of a disaster zone where communications equipment is not a mess. Just be like, hey, we made it through the tornado. This is what's up. I'll try to check in 24 hours. Just so somebody somewhere outside of my disaster zone knows what the heck's going on and might even be able to, set something up if something worse were to happen and I couldn't check in or some case. But the reason you want an outside or an out of town contact is so when disasters happen, imagine that it knocks out the communications and things like that, and everything's a hot mess. There's only like 1 or 2 towers left. Everybody's hitting these towers. Everything's staying local, and it's all trying to go at the same place at the same time. But then the one that goes, and it's like, oh, this doesn't need to go back into this crazy area. It's going out somewhere. It just hits the tower and it goes, and it gets to where it needs to go. You're much more likely to be able to communicate outside of that disaster zone than back with somebody in that same disaster zone. Also, texting is a lot less bandwidth than trying to make a phone call. So if you can keep it to like a single text, keep it short and concise, you have a very good chance that your communication is going to be received on the other end. It's not a guarantee. There's always issues, but you have a much, much better chance that way. Have your go bag stocked for everyone in your household. Kids have their own stuff, pets have their own stuff, adults have their own stuff. People have meds that they need. People have documentation for things. Whatever makes sense for you, whatever you could possibly need in the span of like 3 days or so, think about those things. What's coming up when you think about in 3 days time, what are the things that I need? That's the stuff you should have at least a little bit on hand for. Again, there's tons of great videos out there for go bags and stuff. Make sure to check those out. Always stay informed. I feel like at this point, I've made that pretty clear. Double check your information. Disasters can mean things are constantly changing. So you want to make sure that you and your family and your community have the right info. So even though at the beginning of the day, the city says, okay, this is what's going on, by the end of the day, that operation might have been successful or not successful. Maybe now things have changed. So make sure you're checking it at least as often as you're able to see what's going on. Check your NWS weather radio's batteries and settings before things happen. So ensure it's configured properly for your area and then it's set to alert you. I'm sure there's a lot of other stuff that I haven't thought of. So if you've got any good tips, feel free to throw those in chat here. I loved all the comments that we've had so far. If anybody's got like a cool tip that's maybe would be applicable to you that you've used in the past or that you can think of that maybe I haven't covered, love to share it here. Other than that, if you only remember like one thing about safety and preparedness, remember this: before I do anything, I ask myself, would an idiot do that? And if the answer is yes, then I do not do that thing. Very straightforward. If you're thinking about doing something, you're like, man, I don't know, like I'm really confused. If it seems like a dumb thing, don't do it. Try to be safe. I know it sounds really simple, but like just try to think through stuff. There are definitely good choices and there are bad choices when it comes to disaster and preparedness. So try to be thinking, try to be on your A game. Try to have plans in place so you don't have to be thinking through these things. You can just fall back on your plan. So key points: maintain your situational awareness. Conditions are continually changing. Always have 3 or more ways of receiving severe weather alerts. Have a plan, know the plan, practice the plan, and use the plan. Communicate clearly, especially as a spotter. Information is what makes us invaluable, but only if the information is accurate and timely. Anything I didn't cover that you wanted to know, feel free to ask here. questions about us, about the team, about the Independence EOC, I'm happy to answer. You can find us on socials at Twisted Skies WX or the EOC at In-Depth Mo EP. Let's see. Prepackaged pet carriers if you have to leave. Yep. Anything you can do to save time on the back end, having things ready to go is great. So yeah, that's pretty much it. I appreciate everybody being here. I hope this was helpful, educational to some degree. Yeah, if you guys think of anything, even if it's after we get off the call here, you can always holler at us. Messages on Facebook, messages on Twitter, wherever. If you think of something, if you want to know something, if you want to bounce something off of us, we'd love to try and help point you in the right direction, get you where you need to go. Again, we've got Discord. You can join us for kind of day-to-day conversations. We've got a podcast. If you look up, let me type it in here. So, keyboard working. You can look it up that way. You can probably just look it up as Twisted Skies or look it up as Weather Forecast. We've got one episode. We've got another that we are going to be recording next weekend, and hopefully another one very shortly after that. Right now, it's just our introductory, but we've got a gentleman from the Kansas City EOC that's going to join us to talk about, again, more preparedness type stuff. We're going to talk about like problems with like power grids and like infrastructure and like why those things are a big deal and what that means for preparedness for us as individuals. We're going to kind of cover a lot of things there. And then hopefully the next episode, if we can get everything straightened out, we're going to really do a deep dive on the Oak Grove tornado. So, you know, if you like podcasts, if you like to listen to something, we're supposed to let you know if you're interested. Yeah, absolutely. If you're interested in being a storm spotter with the Independence, Missouri EP, or if you're out near Oak Grove, if you're in the Independence area, talk to me. If you're out more near Oak Grove, talk to Pete. If you want to, if you've got a lot of time and you're able to kind of float between, yeah, hit us both up for sure. Just message us after class through Facebook Messenger or something, and we'll be happy to talk to you, get you on the right path there. But yep, find us on Discord, let's see, Facebook, Twitter, Instagram. We're all over the place. So wherever you find us, shoot us a message if you've got any questions. If you need to know something, you know, we're humans. We don't know everything, but we'll at least try to get you on the right path. So take care, everybody. Any other last questions before I sign this thing off here? Just want to make sure. And we will post this video. It'll probably take me a while to get it on YouTube, but we'll post it up for everybody. And I'll post the slides. So you can have the slides, you can rewatch the video, kind of go along with us or whatever, have it down the road. But thank you guys for being here. Stay safe, and hopefully we've got some warm weather soon. But take care, everybody. I'm going to go ahead and stop this thing here. All right, stop.